Should we start now? Start. Okay, so good morning, everyone. I just welcome all participants here to the IIT Guwahati. Thank you for coming and attending this course. Hope it will be a learning experience for you. So I also welcome Professor Prabhat Mishra, who come all along from United States of America here for this course. We also have here Professor T. Bharat, Head CET, Professor Sukumar Nandi, Dean of Administration, IIT Guwahati, and Professor T. Venkatesh, Head of the Department, Computer Science and Engineering. I request all of them to please come to the dais. So to start the event, we have this lamp lighting, which is kind of traditional in Indian. Any program, we usually start the things with this lamp lighting. So I'll request all of the dignitaries to please light the lamp here. Okay, so let's start the proceedings now. So in this, the approval process had take bit time, and we got the approval around November 2024, and then the mandate is that we need to do it by 31st March. So based on the availability of our Professor Mishra, so we decided this schedule. We have, I think, one day problem this Holi. We'll see how we'll manage that in between. But I think there are a lot of interest in this course, and I got almost 190 applicant who applied for this course. But I think because of this timing where it's middle of semester, few people could not come. But still we have 68 registration in this course, and few of them will join online, and we have also few IIT Guwahati students including in this 68. So it come directly in the session, they probably have classes and all. So let me just thank Professor Mishra coming from USA. He is ever energetic person. He is told me today morning he is 53, and in the guest house they told that which course you are coming for registration. They thought he is a student coming from some workshop, right? So he's that energetic, and sir, I mean, is kind of role model for many faculty member like me. We follow him for a long time. We follow his work ethics, his energy. When I can just give you one instance, I asked CET on Wednesday, can we make some modification in the course which was proposed 1.5 years before? We want to add some new thing, and they say yes, you can always do that. And then sir was that time in airport, and he make a call from airport to me, and we talked for almost 40 minutes and finalize the course. So this is how he is supportive and energetic. We also have here Professor Sukumar Nandi. He is an expert in this domain, cybersecurity. That's why I invited him. He is Dean of Administration, is something his post, but he is our professor in our department in computer science engineering, and he's also kind of a one of the architect of this IIT Guwahati. I would say from day one he is in IIT Guwahati, and whatever you see in this IIT Guwahati, many things is because of his initiative. So thank you, sir, for coming here. We also have head CET, Professor T. Bharat. She is also very supportive. Any request I come, he never said no, and he is very busy person. I can tell you, so many GIAN courses is happening, so many NPTEL courses happening, many online courses is happening, and he is always supporting every activities initiated by the faculty members. Thank you, sir, for supporting all us. And we also have Professor T. Venkatesh, head of the Department of Computer Science Engineering, and he is also very energetic and supportive. So any faculty come up with any initiative, he always support us and try to provide all the assistance from the department. And he is also kind of a go-to person in the department. Any problem we face, we always go, and he always support us. So thank you, Professor Venkatesh, coming here. So without much delay, I want to invite Professor T. Bharat to say a few words about this course and overall of CET here.
Thank you, Dr. Chandan. Good morning, all of you. And also good afternoon and good evening for others who joined from different countries. And it is heartening to see so many students, faculty, and other people from industry join this particular course. Not only just the participants in the offline, but there are participants in the online mode and joined from different countries. And I take this opportunity to welcome from all the behalf of Professor Nandi, Professor Venkatesh, Dr. Chandan. I take this opportunity to welcome Professor Prabhat Mishra from University of Florida for this particular GIAN course, who is a global expert on AI. And also I take this opportunity to welcome all the participants to IIT Guwahati and Center for Education and Technology, CET. And the GIAN, Global Initiative for Academic Networks, which is a Government of India's initiative started in 2015 for leveraging the expertise from the global countries, global institutions, to come to India and then engage with the scientific community in India and share the knowledge and engage in networking and joining together for enriching the knowledge in different areas. So far, 3 phases have already completed, and this is the 4th phase where we are in. From IIT Guwahati, we submitted 20 proposals, and 13 have been accepted already. And this is the 7th one, which is going on currently. And this is on AI. And there are so many experts from computer science, I should not explain. I don't want to explain also on AI. We know the importance of artificial intelligence currently, and how this is actually garnering a lot of importance in several areas. And this particular program is on cybersecurity and how the AI is leveraged in cybersecurity for different applications. As Dr. Chandan has already explained the detailed details of the course content. I don't want to delve into that particular aspect. But this GIAN is a very important thing, and which is conducted through Center for Education and Technology, CET, which has started in 2002. And Professor Nandi is here, who was the, played an important role in developing this particular CET from the beginning. And CET over the time has undertaken several programs, including NPTEL MOOC courses, and from IIT Guwahati alone, we have developed more than 750 courses, which are all up online on YouTube on several aspects, several courses. And interestingly, this particular GIAN course also, the content can be converted to NPTEL, because the recording is also going on, and some aspects can be included, and it can be made a NPTEL course as well. I would like to see such kind of a development, and a contribution can be made in developing a course. And from CET, I extend complete support And I encourage all of you to engage with a global expert who is available for 10 days, nearly. And interestingly, when we go to a conference, we hardly get a chance to talk to a global expert. But in this case, you are also here, and the global expert is also here. And other experts from computer science are also here. So this is a wonderful opportunity for you to engage and completely extend your, your all inhabitants, etc., and then engage with this fraternity, and then develop a network, which is the main objective of this particular GIAN. I wish you good luck and great success of this particular event. Thank you so much.
Thank you, Professor Bharat, for this motivations for the students. And I think it's, as sir mentioned, it's a wonderful opportunity to talk to Professor Mishra. He is super busy person, I can tell you. And he's one of the star in this domain, in the cybersecurities and all. So it will be a great opportunity for you to learn from him. So I'll now request Professor Bharat to welcome Professor Mishra formally here with. Okay, so Professor Nandu. So I'll request Professor Nandi to welcome Professor Mishra. Thank you, sir. So I now request Professor Nandi to come here and say a few words, motivating the students.
Hello, good morning to all of you, including good evening to the whoever joined from other countries. My friend Prabhat Mishra is here. I am delighted that he is here. My colleagues are here and they have already spoke and they are going to speak again. All participants whoever eager to learn in this program, I welcome you all to this GIAN course. It's a special course, I put it that way, because there are two main components. One is explainable AI, another is cybersecurity. These two are very big things and they are combined together and delivering this course. It will be very interesting to learn these two things in one way, or usage of cybersecurity in explainable AI or the reverse. In other way, I can say that security in AI and AI in security is a big question. Okay. I hope the expert will speak about security in AI and AI in security. I am giving it little trouble for you. So, because these two are very, very important things, and I happen to be expert in this area, so I am talking like this. So I feel that he will take care of this part, not only explainable AI for cybersecurity. Okay. By the way, I am from administration. My designation here is Dean Administration, so I am from administrations. From IIT point of view, I wanted to tell you all the participants from offline and online is that IIT Guwahati started in 1994, first batch on 1995, till now 25 fifth convocation is concluded. We are going to have 26th convocation very shortly, and we have mentored multiple institute like IIT Patna and several NITs, IIIT Bhagalpur, IIIT Manipur, CIT Kokrajhar. Like this, we have done several activities catering the need of the country We are also associated with multiple institutes like NILET, Jammu, Kashmir, to the south, anywhere, to the west, you go any place, including PSG College, Coimbatore, to everywhere we are trying our level best to help in certain capacity. We are open to all kind of associations with any institute in the form of student coming here, spending time, but finding the proper mentor is the student and the faculty job, and the department and center or school. We have faculty associations with other institute or other organizations or research organizations. So we are helping CDAC, we are helping DRDO, we are helping ISRO, we are helping the defense services. We started also one center, defense services, for upskilling, reskilling and others. That is called Manikshwa Center for Excellence for National Security Studies and Research. It's mainly for the defense services, capacity building, upskilling and reskilling, and also resettler program for Ognivir and others in all kind of their well-being. We are with NILET, helping NILET. We are helping so many private universities. For that, we need association with the faculty members specifically. So faculty or researcher in those organizations can be with us, our faculty members, our technical officers, and make a relations and continue. So we are here as part of the nation building, and those who are ready to part of the nation building, we are with them. So be part of the nation building, because nation needs all of us. Nation is first, rest other can be secondary. So IIT Guwahati has multiple options to associate. We have multiple schools, multiple centers and multiple departments, and multi-level associations are possible. So don't consider this is only for 5 days course. If possible, please be join with us, make your career or your organizations along with IIT Guwahati. Coming back to our department, head is here, he will talk about it. And India first cybersecurity program started as Information Security Education Awareness Project, phase 1, phase 2, phase 3, now phase 3 is running. Phase 1 is happened to be started in 2000, conceptualized in 2004, came up in 2005, and since then we are involved, IIT Guwahati involved. I am one of the members in that group, continuing that activity at national level as well as institute level. Now I have given task to this in our department. Head is now looking after the ISEA project phase 3 at IIT Guwahati, and that ISEA phase 3 is security. Again, what Professor Mishra will talk is security as well as AI and futuristic technology. Basically, it's a futuristic technology, and we have a thematic team which is specifically designed, given to the IIT Bombay its clusters to do it. However, AI and security is everywhere, so it's not one group based activities, it's everyone's activity. So in this ISEA project, there are lot of options available, everyone to join. Sorry, I am talking in GIAN course ISEA, because wherever I will go, I will talk ISEA, because I am carry forwarding that legacy. So basically, we have option for faculty, option for student to be part of any one of the ISEA thematic clusters. There are 50 organizations looking into education and innovations. Okay? And these education innovations, we need people to participate. And each and every person can participate. Those are in formal or informal educations, doing in any sectors, any level can participate in this program. How? One is you can come up with proof of concept, any product, or you want some idea you want to materialize to make a proof of concept. You come to any one of the institute and so that this is the options I wanted to do. If it is, you can convince, you will have a money available for you, 2.5 lakhs will be granted. You have to go through the mentorship. You can come up with product. Once you proof of concept will done, we have a venture capitalist, we have options, patenting and everything can go to a product. And we have innovation challenge, you can compete, you can hackathon, innovation challenge, you can compete. If you get success, definitely your work will be considered at the national level. That is one side. If you are a student or your students wants to participate, can come to any one of the institute, there is mentorship program exist. There is internship program exist. There is research program exist. Combined research exist, as well as any institute wants to join in any one of the 50 institute can be considered as a spoke, and they can organize multiple activities in this. So we have multiple options to carry forward our Indian cybersecurity options, in which AI is part and parcel. Today, we are starting a course on explainable AI in cybersecurity. There is another side of the people also talks about big data, big things, as well as the LLM, large language model. How large language model can be used, that is also another part. I don't know what Professor Mishra will talk. I think it will be very interesting, enjoyable and learning experience. We have to put mind, we have to learn. If possible, we have to continue our journey in cybersecurity and contribute to the nation. Hope this will be very interesting and thought-provoking and understanding for future career. Thank you for coming and joining in online or offline this course. Hope to see you in future also similar courses. Please enjoy this course coming 5 days. Thank you.
Thank you, sir, for your encouraging words. So, as sir mentioned, this course is something where we try to use AI to identify the security flaws in the system level or in system level or software level. So, Professor Mishra will talk about more about the course, few minutes. Just to add that I have almost 100 plus requests for online registration, but since I want to make this offline, so I discourage online registration, but I am only allowed very few specific people, specifically from outside. So we have one person joining from Sri Lanka, one from Oman and one from England. So these 3 people I allowed, and 3 faculty member from different colleges because they have course working. So I have only allowed those people join online because I just want this opportunity to that we have the physical offline interaction, and that is always useful rather than online, right? So that's the motivation. Otherwise I would have maybe more than 200 plus attendee to this course. But I think people who coming here around 68 will thoroughly enjoy this course, and Professor Mishra is a passionate teacher. I have attended few of his lecture, many venues. You'll enjoy definitely. So without losing much time, so I'll now request Professor T. Venkatesh to talk about our department, opportunity in the department, and in general supporting our course.
Good morning to all of you, those who have joined here as well as in the online mode. It is my pleasure to welcome Professor Prabhat Mishra Professor Prabhat Mishra has done several courses with the department. Last year he was here with us for doing a quantum workshop for 3 days. I have heard him many places. He's very passionate teacher, very energetic, and I hope you will all get engaged with him and learn a lot in this area on cybersecurity and explainable AI. And from the department side, we have quite a few faculty working in the areas of cybersecurity, mainly in the network security and hardware security. And Professor Nandi himself works on cryptography and other areas as well. So we would have about 7-8 faculty working strongly in the overlapped areas or allied areas of cybersecurity. I'm not sure if you would get time. If you get time during the breaks, or the weekends, you can also interact with our faculty in the department. And from the department side, we are looking for motivated people to work in this area. It's always hard to find talented and sincere students, to contribute. Not just students, entrepreneurs or industry people to help us with solving research problems in these areas. So if you are interested in any collaboration, do contact our faculty and get in touch, explore how you can collaborate and contribute. Those of you who are faculty, you can start collaborating and then mentor students, because one thing we are finding is that you must have read in newspapers also, there is a declining trend in people coming to research in general. Okay, this is not a healthy affair for any nation. On the short term, people would flourish well in making money with whatever quant companies, algorithmic trading companies, etc. But on the long run, it's always important to keep nations' research infrastructure going on. Otherwise, you would not have this. You would have a breakage in the chain of people mentoring young researchers and young researchers learning from experienced people. So so it is always our aspiration to do these courses and bring people to IIT Guwahati. As Professor Chandan mentioned, we want people to be here physically, learn directly from the expert, interact with him, and continue forward after you go back to your places. Right? Otherwise, we have seen during the COVID time, many online sessions, and we know what they have contributed. I don't think online learning helps much if you do not have this kind of physical interaction happening, right? So I welcome you all and hope you have an enjoyable 10-day session, and look forward to see some of you and your institutes people here in our department work with us and contribute to this area of cybersecurity. Okay, thank you, Professor Prabhat Mishra. Thank you for being here. It's a 10-day long session. I was initially thinking it's for 5 days, but you have a lot of energy to speak for 10 days. And I have seen it's a packed session continuously. He takes a lot of lectures, and you would enjoy. You would not get bored with him. Okay, thank you, Professor Prabhat. Okay, and welcome you all once again. Thank you.
So thank you, Professor Venkatesh, for highlighting the course importance and about the department. As sir mentioned, we need energetic people, right? Just like Professor Mishra, we need few generation Professor Mishra as well. So just to give little bit background about Professor Mishra, he did his BTech from Jadavpur University, Masters from IIT Guwahati, IIT Kharagpur, and then did PhD in UCSD, and then he's a faculty. I mean, he was in industry, many industry, 5-6 industries, and then he joined University of Florida, and he's a faculty member there. But he, because being Indian, I think he has very strong connection with many faculty from India, not only IIT Guwahati. He also collaborated with IIT Kharagpur, IISc Bangalore, IIT Kanpur, many other institute, and he is kind of mentor for us. So when we are new generation of faculty member, and we usually get motivation from Professor Mishra, and he is, he is super knowledgeable person. When he started in formal verification, then goes to quantum computing, and he is one of the leader in quantum computers as well, quantum computing work. And obviously, cybersecurity, explain AI for cybersecurity. He has more than I think 200 papers, 7 or 8 books he has written, and I mean, if you start doing research, you have to follow his work, I mean, to get what is the state of the art here. So what I request now Professor Mishra to come here, talk about little bit about the importance of the course, general overview of the course, and then we will conclude.
Good morning, everyone. Can anybody say hello from online so that I know you are able to listen to us? Please unmute and say hello.
A very good morning, sir. I
Oh.
am Basant from Muscat.
Oh, good morning, good morning. Thank you, thank you.
It
Okay.
really is I'm fortunate, I can say, because the way you are providing all the information, and in the future endeavor, I am going to be benefited. Really, it's a wonderful platform, sir. Thank you so much. Thank you so much.
Thank you for your kind words. Good morning, everybody. I can assure you, I don't know how much you invested on this one, you'll get a huge more return than that. I always make sure anybody works with me, professor, student, you get at least 10x to 100x return on investment. You'll enjoy it, and we spend behind the scene. Professor Karfa and I spend an enormous amount of time developing slides, planning it, just to make sure you actually understand. And I'll tell you just a story of success story. So I first came here because of Professor Nandi. Professor Nandi looks like so young, but I know him since my day of masters. He finished his PhD. I was doing masters. He joined here. Then he brought me here at 2017, and I met Deputy Secretary of India or all these big shots, and that's how my connection started with IIT Guwahati. And I kept coming, and the amount of time I spend in India, I think including my family and everything, if you think of that as 100 days, I spend 90 days in IIT Guwahati. Most of my time I spend here, less time everywhere else. It's like my second family. So when we designed the course, we basically wanted to give you a flavor. I didn't want to make any assumptions. So we start with basic machine learning, even the first chapter of machine learning book, and what it is, how it is, without making any assumption. If you do know nothing, that's actually better for this course. And if you know something, my first job would be to make you unlearn, because most of the people, what they learn, that's actually wrong. My second, third, fourth PhD student came in. It took me 3 years to get rid of that unlearning process. I'll give you exact example. This student came in with 50 papers in the resume, and it took 3 years to publish one paper. So whatever the way they learn, no disrespect to the professor with whom he or she wrote the papers, basically do any crap and submit any crap. Copy from anywhere, do something, just stay away from all this stuff. Because academic honesty is extremely important. Very few people can tell you that they never had a cup of tea in their life. Forget about coffee and wine. I am one of them. Honesty and integrity is extremely important. If you don't have that, you have nothing. You can earn whatever money you are taking a bribe on left hand, and you are expecting your son would be honest and listen to you. That's not going to happen. You are the reflection of the world. So whatever you do, I got bored with my professors because they are telling crap. Either they didn't learn or their teacher didn't learn. I can't do that to you guys, right? So that's why we took a lot of time. Most of the thing may seem silly. If they seem silly or so obvious, then I'm doing a right job. Everything will simply build steps by step. We'll talk about simply first AI. Then when you feel comfortable with AI, then we talk about little more advanced version, and up to all the way to large language model. Not all the hoopla about large language model good or bad. We don't want to waste time on that. How do you build those steps? What is the stuff that's making it work all the way? And we'll throw a lot of jargons, but I'll build in such a way you'll never get bored, whether it's generative adversarial network or diffusion model or reinforcement learning. Whatever I introduce, it will seem obvious to you. Once you are done with the AI, then we move to cybersecurity. I'll talk about those problems: software security, hardware security, firmware security. Professor Karfa will look into compiler security, tool security, those kind of things. So when all of those are covered, then we'll try to see how do we apply AI to solve cyber security problems. Now, Today Professor Nandi put one more task on me. I somehow have to accommodate. How do we do the opposite? How do you look into the security of the AI itself? But basically our schedule is totally tight and full, and the way my teaching actually becomes successful if you participate. If you just come in and open your phone, right on the first day you decided to give up with your life. Phone off. There should be no call coming, no call going, no text, no messaging. Unless somebody in the family is going to a hospital for emergency, about to die, you are not going to open your phone or anything. Piece of paper and pen, you ask question, we discuss, brainstorm, during break. Remember, I don't take tea, so I eat very little. So there is a lot of time throughout these days. Saturday, Sunday I am free. Feel free to come wherever I am. We can talk and discuss, and that's the way to learn. All other forms of learning like going to Rajasthan and Kota, doing coaching, this is cheating. There is only so much you can go in life in cheating. I come from a family where there is no food to eat. I came all this way only because of honesty and hard work. If you don't work hard, if you are trying to achieve because your uncle is famous, auntie is this, you will go only certain distance. The distance a throughput ball goes is all depends on your force, tactic, all of those. So building on somebody else's base, the problem is when somebody took the carpet out of you, you will fall. And then you can blame Narendra Modi, Mamata Banerjee, whoever you want to blame, you can blame. But really the problem is you have to blame yourself. If you build a base, whether economy goes down, IIT Guwahati go out of business, nothing will happen to you. You will get stronger and stronger. So if you want to become like me or better than me, then please ask questions, please participate. And in fact, if you ask me 100 questions, I will be less offended than you are basically not learning anything, you have no idea, and you decided to give up after the first day. Even if question like, I have no idea what you are talking about, that's a very pleasant question to me. That's pretty much all I have. Anything else, Professor? Thank you.
Thank you, Professor Mishra, for saying the reality, right? So you should have the reality check. Before concluding this session, I will not extend this session because all dignitaries are very busy. They have administrative work. I don't want to extend their stay here. So before concluding, I must thank the people who helped me to organizing the course. Obviously, Professor Bharat, he helped me a lot in this whole process, the approval process, all these things on time. I must thank Kaushik from CET. He is the kind of the backbone of this course. He take all things, including your this welcome kit to everything, right? So he managed everything. So thank you, Kaushik, for helping me. I also must thank two of my students, Ishwar and Praveen. So they are also working in background. Yesterday we have India-New Zealand final match, right? And my student was airport to pick Professor Mishra. So this kind of thing they are doing on the background, and all the emails you are getting, all the hostel booking, all the process here. So everything they are managing. So thank you, Praveen and Ishwar, for helping me in conducting the course. And I also thank Professor Venkatesh for supporting all the necessary help from the department, and Professor Nandi to help all the administrative support. Ideally in this institute is so peaceful that we never get trouble, right? Anything you just give a call to Professor Nandi, okay, you do that, it will happen, right? So I never fear to call Professor Nandi or Professor Venkatesh or Professor Bharat. So anytime I don't need to write email and all, sir, I need this help, and just give a call and they just help me, right? So this is how smooth system we have in IIT Guwahati. So I welcome again all of you on behalf of IIT Guwahati to this course, and I sincerely hope that it will be a enjoyable course for you and you will learn, and probably it can be a stepping stone for your career for the students. Thank you everyone. So we'll have a tea break now, and then in half an hour we'll come back and start the course. Thank you.
Thank you so much, sir.
Okay, so we'll come back at 10:30. Okay, so we are 15 minutes delayed, so we'll start at 10:30 here. I think tea and snacks will be outside somewhere, so please have the tea.
So actually, I wish that I should have attended this in the first week offline mode, but due to some family circumstances, I have to attend the first week in online mode. But we look forward to having the second meeting offline mode, and we look forward to learn a lot from this. Thank you so much, sir.
Okay. Okay. So we'll okay. Thank you. So please come back at 10:30. Online participant, please take 15 minutes break, and we'll start at 10:30. Okay. So you can take a 15 minutes break now. Okay.
Sure, sir. Thank you so much.
I have modified this, sir. So this is not the final one. So I'll give you the final one. So we'll start at
10:30 is the program.
9:30 to 10 inauguration.
10:30, sir.
just think that you are not outsider, you are part of this course. Okay, so feel free to interrupt any time to me and Professor Mishra during the course and ask questions. Okay. So
Sure, sir.
yeah, we will make this course interactive, right? So as Professor Mishra, it's not a one-way traffic. So please make this interactive. Stop us anytime. Okay. So we'll start now. So this session is kind of informal, where we will primarily talk about what we are going to cover, what is the course content, and everyday schedule, everything we are going to talk about. And say in the inauguration session, I did not talk more about Professor Mishra, so I will talk about his profile and all, right, just to make you aware about the entire thing. Okay. So as you know that this course is going to happen for 10 to 21 March, 2 weeks, this Monday to Friday, next week Monday to Friday, Saturday, Sunday is holidays, and this course instructor I am Chandan, and Professor Mishra from University of Florida, US. He will be the lead instructor, and he is going to talk about 80% of the course content, right. I will just cover few of the topic. Okay. So I must introduce Professor Mishra. So he is now the US Research Foundation Professor at University of Florida. He also leading the CISI Embedded System Lab. His research interests include embedded system, design automation, hardware security, energy aware computing, formal verification, system on chip verification, validation, machine learning and quantum computing. So sir has completed his PhD in 2004 from University of California, Irvine, and this is the year where happens to be I completed my BTech. Okay, so sir, Professor Mishra has published 9 books, 35 book chapters, 23 patents, more than 200 research articles in top tier venues. As sir mentioned, we should not publish in junk conference and journal, because it's actually create negative, it just add negative value to our profile effectively. So he also have NSF Career Award from National Science Foundation, IBM Faculty Award, 3 Best Paper Award, ISQD 16, VLSID 11 and CODES ICS 2003, and this year he is the TPC chair of the same conference. 8 Best Paper nominations, ASP DAC 2023, date 19, ASP DAC 17, Nano Arc 13, VLSID 13, date 12, DAC 2009, VLSID 2009. And I can see most of the conference are the top tier, right. So DAC this year I think 2500 papers submitted, only 200 odd accepted, right. This is how competitive those conferences are. Professor Mishra also has this EDA Outstanding Dissertation Award from the European Design Automation Association. He also received Doctoral Dissertation Mentoring Award and International Educator Award from the University of Florida, I think this year in February. So congratulations sir again. And he has lot of projects, right. So every time I got at least once in a year I got an email from sir that, do you have a good student, can you recommend one good student to my project, I have this $1 million funding from NSF or this and that. So he has lot of funding, and he I think got many students from our IITs. So and he already involved with lot of government agencies like NSF, AFRL, ARO and DARPA, and industry like SRC, Semiconductor Research Corporation, Intel, Cisco, Harris, IBM, I mean almost every companies, right. And he is fellow of American Association of Advance of Science and fellow of IEEE. So if I try to keep speaking about his profile, probably I need 1 hour, so I will not elongate it further. I was seeing his website and just copy few of the points from there, it is a long list. So welcome sir to IIT Guwahati once again. So I will talk little bit about me and my research group, because this is an opportunity for me to also give a publicity of my research as well as my students, whatever they are doing in this institute. So I did PhD from IIT Kharagpur in 2011, BTech in 2004, then MS and PhD from IIT Kharagpur. and then I joined Synopsys India, which is a EDA company, electronic design automation company, where I worked for 5 years, and 2016 I come back to IIT Guwahati as a faculty member, and since then I am going to retire from here. So, I will be another, I think 22 years or 23 years here. So, we primarily, my research group, I actually lead the lab called AVS lab here, Automation Verification and Security Lab, which primarily focus on formal verification, compiler security, hardware security, electronic design automation and machine learning for EDA. We have some awards as well. So, some awards come like this time I got this Google India Research Award and Google Silicon Research Award this year. Also, I got Qualcomm Faculty Award in 2021. I am and some other funding, but everything because of my students, right. So, because of their contribution, we are getting some recognition. So, these are the two teaching assistant. I think you already got multiple email from both Ishwar and Praveen Karmakar. Both are my PhD students. Praveen is a senior PhD student and Ishwar just joined with me. Both of them is going to work in the similar area. So, I asked them to also join in this course as a TA, teaching assistant, as well as a student, right. So, Praveen works mainly on this hardware security side, on the IP piracy and all, how do you make your design protected against IP piracies and all. Ishwar is going to work on this machine learning security, what Professor Nandi was talking about at the start of the things, right. So, we are going to cover one session where which would be the kind of work Ishwar is doing, and there will be one complete day where I am to talk about what Praveen is doing here. Okay. So, so the Praveen part I will talk about this logic clocking and how do you basically protect your design so that people cannot copy your design, right. So, the main problem happening in that domain is like if you try to have a design which is a intellectual property and somebody can steal it, right, when you give it for fabrications or in the entire design cycle. So, it is kind of you lock your design and give it to somebody so that you give the design, but they cannot unlock and use it, right. So, something like this. So, a lot of research is going on that direction, I will talk about that, and Ishwar is going to happen on this how to try to implement the machine learning model in for in the edge and IoT computing devices. So, where you try to have a, it is not that you are running your machine learning model in cloud, rather you have a dedicated chip which is called hardware accelerator of machine learning. Okay. And then whenever you have this, the security, right. So, nowadays lot of work is being going on, lot of research, lot of interest that you try to attack this machine learning model running on the edge or IoT devices, and Professor Mishra will talk about lot of such attack techniques, how do you kind of find out the backdoor of the designs, and through backdoors basically for the machine learning model you can get the weights and all, right. So, he is working on that. I will in one session I am going to talk about the machine learning security, right, that will be on Wednesday. So, as I mentioned, this is the lab. Please feel free to visit my lab in just adjacent building, top floor, and you can ask Praveen or Ishwar to take you. You can talk to other students as well. So, I have 7 PhD students currently, and recently my focus is on cybersecurity, and this I can tell you honestly, this course was proposed 1.5 years back, right. So, that time I was trying to think about I also move into this domain. There are a lot of I was actively moving into this domain. So, I thought it is not why, I mean as a student I can also learn from Prabhat Mishra, and that can be a golden opportunity inviting him here and ask him to speak here, so that I can also learn from him, and that was my motivation to offer this course honestly, and then it goes a long way and now we are here. So, we have students where Nilotpala also works on hardware security, Praveen I talked about, Bhavesh and Akash work on ML for EDA, and they have just joined. So, they have not started their research yet. So, we have a big group. So, we have quite few MTech students. So, these are for 1 year project, right, masters and PhD students. So, this year I have 6 MTech students who are working on either this security or EDA, and I have 11 BTech students who also work with me. So, I have kind of a quite big group, and we have quite good publications nowadays. These are the areas, and if you have to get more information, you can visit my website, you can get more information about my research, and Dr. Sukanta also is an active member of this group. Little bit about more that, so we get lot of funding nowadays from industry, and I want to highlight the specifically in this slide the good things doing by my student, right. So, forget about the first two bullets. So, we get lot of funding from industry. Praveen got Qualcomm Innovation Fellowship this year, I mean 2024 we have the project which so Qualcomm is supporting his research. Priyanka who work on compiler security, which is another topic I am going to cover in this course. She also got fellowship from Qualcomm. We got 2 times fund from Intel, again this is kind of fellowship to my students, 1 time from Samsung, and there is one logic locking competition I want to highlight this one also. It is basically on this logic locking what Praveen is working, that they give you challenge, that they give you lock design and they ask you to break with any techniques, right. And it is a worldwide competition, so in which happened for 3 years, and each year we participated, and first year we got the 3rd place, and the next year we got the 2nd place, and then we got the 1st place in the last year. So, we basically improving, you can see, right. So, in an international level also our work is getting recognized, and we are able to break circuits there which has more than 10,000 keys. And Praveen has break certain circuit which is locked with 10,000 keys, and you are able to break it, right, without any other external support. Our work, we try to do good research. So, if you see the last 4 years department based MTech thesis 3 times got from my group, right. So, people are doing good work even from my MTech students. I think 2 point is missing there. This year I got 2 best paper nomination, both are Nilotpola's work, one in cases where 3 paper got nominated, unfortunately you do not get the best paper, and also VLSID, there also we got the best paper nomination, both are Nilotpola's paper, and also we got this best paper nomination in another conference in a hardware security conference called ASEAN Host in 2020. So, this kind of summary of achievement of my student, this is a good platform to highlight my students achievements. So, we as SIR motivates us, we usually publish in top tier venues. I usually do not publish in XYZ conference. So, these are the kind of top venues are used to publish. As I mentioned, we have funding from industry as well as government. I have already worked with Intel, where I am working with Qualcomm, I am now working with Google, 2 project funding is happening there. Siemens, specifically Mentor Graphics, Texas Instrumentation on this hardware security side, and they are interested on low overhead hardware secure design, IBM as well as Semiconductor Research Corporation, and we also get government funding like IIT Guwahati give me some startup grant, then 3 funding from ACRB. One of our focus nowadays, we try to make our research accessible to the community. We try to decided now any good work we are doing nowadays, we try to make them available to the community. So, we try to make our research open source. So, many of the recent work last 2-3 years, we make this work available to the community through GitHub. So, this is the detail of funding which you can skip. So, I will now talk about the course. I just take few minutes to give my advertisement to my group, my research. So, so as you mentioned, it is a 2-week course, it is a bit long. So, every day we have 4 hours of lectures, okay, lectures or tutorial, whatever you call it, is kind of lectures you can say. So, this week we have 10 to 14 March, and then next week 17 to 21st March, Saturday, Sunday we will not have any classes. And timing, the way we did it, like so today it was bit early start, so to have this inauguration seminar ceremony, but we usually have 10 to 11 one lecture, and then we have half an hour break 11 to 11:30, then 11:30 to 12:30 we will have the next lecture, and then we have a lunch break of 1.5 hours. We do not able to arrange lunch for every student for all 10 days, that much funding I was not having. So, you have to take food, I mean either hostels or there are a lot of canteens. So, you can take help from Praveen, but we will and then in the lunch break we will again start from 2 to 3 the lecture 3, and then again we have 30 minutes break, and then we have last lecture from 3:30 to 4:30. So, that will be the schedule for every day, and we are going to provide you tea and some high tea, I would say, both the break. So, that is kind of good platform where you can discuss yourselves with us and all, right. So, that is the overall timing. So, I will now talk about more about this course. I think sir will give you more highlight about the course in the next lecture. It is basically explainable AI for cyber security, right. So, it is basically how do you how your system or your computer or your electronic system is vulnerable through it is through your cyber way, right. It can be connected, it can be attacked by somebody else, right. So, and usually what happen, or this kind of attack happen when you have backdoors, right. So, that means you have kept your, if you locked your room properly and nobody can go inside, then nobody can break your go inside your room. So, same thing goes for your systems or this, right. So, if you have backdoors, people identify the backdoor and through that they enter and do the damage for you, right. And this so, as sir mentioned earlier, so we try to give you what are the kind of backdoors first, right. So, what are the way people can actually go into your system, right. So, it can be the how do you implement your hardware. So, that falls under hardware security, that there may be some way you have implemented, so that there is a leakage through power or maybe timing. So, that through that they can guess the internal of your circuits. It can be system level, for how do you actually access your cache, how do you basically you manage your memories and all. From there people can try to get into your system. It may be how do you compile your program into system. So, the compiler may not be safe. So, that is basically on compiler side. So, there can be anywhere, right. It can be hardware, it can be firmware, it can be software, I mean everything you have to be very careful how do you design it, right. And we will basically cover first half of the course was those aspects. So, today is kind of giving the overview, right. But usually we will try to cover what are the kind of attacks, what are the backdoors you have and how do you basically design or kind of I mean how people can actually utilize those backdoor to attack your system, right. And then the second part is explainable AI. So, nowadays AI has application in every domain. So, we will try to cover what is the techniques of machine learning or artificial intelligence and how people can use those techniques to identify the backdoors, right. You basically identify, and if you know that these are the weakness of my system, you can protect, right. If you do not aware of what are the weakness you have the implementation, you will not be able to protect, right. So, many time this AI can actually help you to easily identify the weakness, right. So, for example, I can give you small example of hardware trojan. So, if you think about a design which has maybe 1 billion transistors and maybe only 200 transistor, 300 transistor being used to add some vulnerability to your design. So, that through which somebody can it can actually make lot of changes to design. It make your clock 100 times slower, or it may just change your control path in your design, so that it started malfunctioning, but it is that small component of your design, right. So, verifying or identifying those trojan, even if, and that is not you inserted, right, somebody in the supply chain have inserted that in your design. It is very difficult to identify those hardware trojan manually or some formal techniques and all, right. So, AI can identify those pattern, right, those particular trojan specifically have some pattern, right. So, if this AI can easily identify many such unknown kind of patterns and you can identify the trojan, right. This is just one example, it can be used for everything. So, what sir will cover is try to see the state of the art research, how basically AI can help you in identifying the vulnerabilities in your systems, in your softwares, and then obviously how do you protect, right. So, that is the third part of the course where you try to talk about that how do you basically add protection in your implementation, so that those attack is not possible, right. So, that will be the overall idea of the course. So, I will now kind of formally introduce the course content. So, we are basically this introduction I am talking about. Then today the second lecture Professor Mishra will talk about this cyber security landscape for computer systems. So, he will talk about all this software, firmware as well as the hardware vulnerabilities as I talked about, and then give some example of recent security attacks today before lunch. And we have two back-to-back sessions today, because my session is bit lightweight, right, there is not technical content here, right. And then second half it is for second half we have two lectures. So, first sir will talk about this basic machine learning techniques, and then basically the entire session is on taking about all the machine learning technique. It has a lot of progress in the machine learning techniques, basically reinforcement learning, neural network, generative adversarial network, and so many things, right. So, we sir will cover the basic machine learning fundamentals in the second half today. Okay. Going to the day 2. So, we have that hardware acceleration of explainable AI. So, that is what I think Professor Nandi was also talking about in the start of the session, that we should also think about how do you help this hardware can help in the machine learning model, right. So, basically he will talk about this hardware accelerator using FPGA, it can be using GPU, TPUs, and all those stuff, right. So, that will be in the first 1 hour, tomorrow morning 2 hours we will talk about all these details. Second half tomorrow we will talk about this malicious software, right, the vulnerabilities in the software. So, malware, ransomware attacks, I think you are all aware of these attacks, antivirus software solutions. And the second lecture sir will cover about this malware detection using explainable AI, right. So, we introduce first the vulnerabilities and then we see how AI can help you to detect those, right. This is how the kind of things was planned. Day 3. So, day 3 I will be talking about. So, I will first talk about this power side channel secure design. So, so this is more on hardware side. So, when you have a hardware implementation, there can be some side channel, right. What is side channel? Is basically the system that hardware is running, but you give some input, it will give you some output, but in addition to that there are some other extra information you can extract when running on a specific input, right. And it can be power, it can be timing and any other things. So, power side channel is one of the powerful techniques to specifically for cryptographic implementation. You try to get out the key, right, when the things are running in your in a say FPGA board or in a ASIC chip, you just measure the power. You remember that attacker does not have the key, but he can control what input he want to run, right. So, he can just control what input is running or the sequence of input, and then the difference is power. They will make the proportion. It is kind of you have say A equal to B plus C, right. You know what is A and what is C, you do not know only B, right. So, you can control your C and you get the output, and from that you can identify what is B, right. So, it is a similar analogy effectively. So, people can control your input and then you can actually measure the power and you can get it. So, what we do nowadays is basically how do you develop your design automatically from even a software implementation of AES or say DES, right. You have a C code for AES and DES, how do you generate a power side channel secure hardware from there, right. So, that is one of the research of us, and I will talk about mostly on that part, right, in the first lecture, where I will talk about how you can effectively automatically generate those hardware, right. You do not need to effectively think about the internal details. So, the tool, what are the things you need to take care inside the tool, so that it can generate you the actual power side channel secure hardware, right. So, that will be the first lecture from my side in first 2 hours. And then the second half, first lecture I will talk about the secure compilation. So, here we basically show you that compiler can actually cannot trust the compiler, right. So, we usually when you write a C program you use GCC to compile, right. We will show you that GCC is not safe, it can introduce lot of leakage in your program, right. So, through that leakage, information leakage, people can actually get the internal information of your implementation, right. So, we will talk about the secure compilation, we will see how we can actually detect, how do you quantify the information leakage of a program, and there are method how do you identify or verify the information leakage in a program. So, effectively if you give a source program and you compile it through say GCC, you have the optimized program, how do you compare whether this is more secure or this is less secure than the original one, right. So, I will talk about those techniques. And then the second half I will talk about the security of machine learning model as I talked about, which Ishwar is working. So, we will see that what are the way you can actually break the machine learning model, and we will talk about 2 techniques which can actually break not the big models, but the medium size model easily, right. It is running either through scan chain or side channel, they can get the weights and biases, right. I will talk about them, and then we will talk about some protection on which we are working here. So, that I will talk about. Then in day 4, so it is again by Professor Mishra. So, in which he will talk about this assertion based security verification, So, generation of security assertion, test generation for activating assertions, dynamic refinement of the assertions and formal security verification. So, format security verification. So, I will talk about what is assertions is basically the properties, right. So, you have a implementation, you guarantee that at this point this cannot be true or this must be always false and so on, right, or if this happen within 2 cycles something must be on and so on, right. So, there are those are called assertions, and whenever somebody designs the design make the design, they also know what are the correctness properties. It can be functional correctness or it can have also properties for security verification, right. So, what sir will talk about that how do you generate those properties, what are the way you can improve those assertions and then how do you verify those assertions, right. So, these are the kind of things sir will cover enter on day 4. Day 5 the Trojan that I talked about, the hardware Trojan is one of the most researched area I would say, in which people talk about, and it is a reality. There are a lot of instances people have identified Trojans in the chip, right. So, we will talk about sir will talk about what is hardware Trojan, then how do you basically design those Trojan and then how do you detect those, right, using statistical technique, then side channels, and probably sir will also cover on this AI technique for this hardware Trojan detection, right. So, the day 5 give to Trojans only, right. So, either what is there, I mean how do you detect them using standard technique like statistical state generation, which maybe sir first PhD student has done, I think Konad has done work on that, right. And then this power side channel analysis as well as the AI techniques, right. So, that will be the day 5 content. And then day 6 we have I am going to talk about this day 6. Here I will talk about this IP piracy and protection, which I was talking about this logic locking, and we will talk about different kind of logic locking technique, their obfuscation and then attacks. So, it is going to be so lot of, again this is kind of last 7-8 years active domain, right, a lot of people are working on that. So, I will talk about in which level you can protect your design and what are the low overhead techniques which is more difficult to break, and it is kind of cat and mouse game, right. Some people come up with some protection technique, within 6 months somebody come up with some techniques to break it, right, and that this break techniques can be lot of way, right. It can be again formal techniques, the way where we work, Praveen works on this SAT based attack. So, you try to model the attack problem as a satisfactory problem and then you try to use the theorem provers to solve it, and if through the theorem proving you can actually get the keys, right. So, this can be one of techniques. There can be structural analysis, you know that the locking has this structure. So, you try to take the advantage of the structure of the implementation and try to break it, or it can be machine learning based techniques. So, we will talk about all those things in this session. Okay. And if time permits, as Nandi sir was talking about LLM, the large language model for assertions and all. So, if time permits, probably I will try to add one session where I try to, we also work nowadays LLM for assertion generation. So, maybe I will try to incorporate that in the suggestion from Professor Nandi, that how you can use LLM to generate assertions for your verification, right. So, that I will see if we can adjust that day schedule. Day 7 sir will talk about this microarchitectural attack. So, this cache timing attack, Spectre meltdown, these are the very popular attacks, right. And then this load forwarding attack on AMD processor, these are all basically on the system level, right. You have a processor and some things are running on that, from the cache timing or how you are basically replace the cache replacement, from there you can actually extract information and you can actually do the attack. And then second half I will talk about how do you use explainable AI to this kind of attack, how do you detect through AI, right, explainable AI. And then also this adversarial machine learning, where we try to set. So, I think this is, I think we are almost covering what Nandi sir was suggesting, that how do you basically attack on machine learning algorithms or the Trojan attack and defenses on the machine learning algorithm. I think we are good to go, the syllabus has already incorporated those suggestions. Then day 8 we will talk about the various cryptographic libraries. where we try to talk about this design of software and hardware cryptographic modules, how do you implement them, AES, RSA, you probably know all those techniques, and detection and mitigation of security vulnerabilities of the cryptography libraries. So, that we will talk about. Then lecture 9, where we talk about this information leakage assessment of cryptographic instructions. So, this is there are techniques like TVLA, where through which you can actually do this kind of task. So, we will talk about this how do you implement the RISC-V processor and how do you do the leakage assessment of this RISC-V processors. Then this is the TVLA, test vector leakage assessment of the cryptographic algorithm, and basically just do some statistical leak assessment. You can actually identify the cryptographic implementation vulnerabilities of the cryptographic algorithms, right. So, this we will talk about in day 8. Day 9 is basically on NOC. So, entire day it is on the network on chip. So, you basically nowadays nothing is a single system, right. You have network of chips connected together to build a entire systems, and sir will talk about how do basically what are the security vulnerabilities on NOCs and how do effectively detect those, and again this attack detection with machine learning, how can you detect those things, and obviously sir will also talk about is that how do you make this NOC secure, right. So, this is the day where we will invest on network level, right. And day 10 we have this application specific security, the trusted execution environment. This is another very important topic, and context switching of security enclaves and security of classical quantum system, right. So, sir will cover all the recent things, right, whatever the state of the things is happening nowadays, and then we will talk about the future research directions or future direction of this AI enabled cyber security. So, where we are going ahead and what will be the next 5 years landscapes of research in this domain. And then we will have one interaction session. I kept it kind of informal, where we will basically discuss your suggestions, whatever questions you have. So, we will make it really interactive session. We will summarize the course and we will talk about the course and all those things we have covered in the long 10 days. And finally, we have an option for test. So, if somebody need I think this GIAN course be converted into some credit for your courses, right, specifically for the students. So, if you are interested to give this test, please let us know by this week, right, because we have to set the question also, right, we have not set it. So, anybody interested please let us know, and also if you are interested to know what is the benefits of giving the test, I can tell you the test will be very simple, okay. Everybody will get good grade, okay. So, that will guarantee. So, only thing is that if it is useful for you, please get in touch with the CET people or maybe Provin. So, we will tell you what is the advantage of doing that, and please let us know by this week, so that we will set the questions and will come. And then we have this certificates distributions and all kind of concluding, right. So, this is how we have planned the entire 10 days. It is a packed schedule. The 4 hours teaching in a day is difficult, right. Some of you are teacher, you know that teaching 4 hours continuously is difficult, right, and sir will talk the same thing for 8 days. It is a huge effort from Professor Mishra. Please try to reciprocate the energy sir has bring, right, and try to make the things useful for you, and I am going to also learn. So, I am also take this course as an opportunity to learn from sir, okay. So, I will be here for most of the sessions except few sessions where I have to take class in IIT Guwahati, otherwise I will be here, and hopefully it will be a very learning experience for all of us, okay. So, with this I will just conclude this session. This is just to give you the more information about the course content and all. So, we can have some few questions. So, if any questions we can discuss, otherwise we will conclude and then we will again 10 minutes break, and then sir will start the next session. Any questions from anybody? Anything from online side? So, you came all across. I have seen some people came from Gujarat, somebody from South, somebody from Dehradun. I mean, you come this far, right, to attend this course. Please utilize this time you are going to spend in IIT Guwahati. See what are the facility we have here. You may encourage, you may not be the person, but you can encourage your students, your some others to come to IIT Guwahati. It's a beautiful place. It's one of the best campus in India, and sir has certified that. Sir has visited maybe 50 institute, and sir has certified this is the one of the best campus I have ever visited. And we have beautiful facilities here, and it's now a maturity institute, right, 30 years old now, and we have lots of new department, lot of centers are coming also. We have now data science department, we have cyber physical system center, we have now health science centers. So, we have so many things, right. I will encourage you people to visit or basically go to our website, see if you have something match with your interest, meet the professor, right. So, this is one of the advantage of coming to places, right. And still now say we spend so much of money to visit for a conference, right. A conference talk is giving you only 15-minute slots, right, but we still visit, right. We still go to conferences even in US, UK just to meet people, right, make the collaboration happen. So, this can be a good opportunity if you are interested to talk to any professor in IIT Guwahati, you can just go visit him, just take an appointment, talk to him, or if you want to visit to any specific lab. So, all these opportunities there, right, you will be here for 12 days, it is a long 12 days, right. So, make utilize of that particular opportunity, and obviously feel free to interact with Professor Mishra, take his suggestion, his advice in your research, whatever you are doing. Okay. So, that is all from my side. Anything we can address, any questions you have, anything about the course content, anything we can discuss. If nothing, then thank you again all of you. So, we will have it is now, we will maybe go ahead with the timing, right. So, maybe we will start at 11:30. So, you can take this 20 minutes break and come back at 11:30 here. Okay. So, we will start at 11:30.
Thank you, sir.
Good morning, it is time to begin. So, what we are going to do is briefly, because the title of the course is Explainable AI for Cybersecurity. So, first day the way I thought, let us describe those two words, what is cybersecurity and what is explainable AI. So, all we are doing this whole day is defining two terms, and if you understood at the end of the day what those two terms mean from different perspectives, that we have done our job. So, first day we are basically going to talk about what is cybersecurity, or to be precise, what is cybersecurity landscape, and the way we are going to talk about briefly introduction, and then we are going to talk about what are the common weaknesses and common vulnerability. If you want to become a saint, the first thing you have to understand what is keeping you away from your sainthood. So, for attacks the similar analogy is what are the common weaknesses and what are the vulnerabilities. If you are thinking those two terms in dictionary, if you open it will look same, but then you have to think carefully. The people who are saint, they try to get rid of 4 or 5 problems most people have, like they are interested in food. When they look at, if I am a guy, I am looking at a girl, I am attracted, all that stuff, or attracted to drugs, drinks, whatever it is, money, fame, not doing anything, becoming rich, whatever those weaknesses are, those are weaknesses. How it differs from vulnerability? If somebody is able to exploit that weakness and fool me, then that becomes a vulnerability. Example, you are getting all these spam calls to become rich quickly, all these Rose Valley and all that Sarda scam, they are trying to tell you they will give you double, triple, quadruple. None of us, even educated people, pause and think, how is it possible on earth? Bank gives you 4, 5, 10 whatever percent interest a year. How is it possible some magical association will give you 10%, 20% per month, when you know the agent is getting 20% cut, everybody is getting all. So, you give 100 rupees, eventually what gets deposited is 40 rupees, and you are getting like 10 times return, except in education, nowhere it is possible, and nothing is free. These two things somehow most people do not understand, that is why they fall for scam, then go to bank and either go to bank to tell I got scammed, or to go to the police force. They should not go anywhere, they should swallow their pride and greed. That is the weakness, that is the vulnerability. Another classical example is there are certain types of birds, they are very expensive in many countries, whether Amazonian rainforest in USA, but they are very rare to find. That is why those birds are expensive, meaning whether people are eating them or petting them, the way hunters hunt them, because those birds, like any human being, they are attracted to opposite sex. So, they all they need a whistle to play the whistle, which will produce the sound of a mating call, and that bird will come out thinking another opposite sex is calling, and that is it. It is their destiny, see, they will be killed. So, their weakness for attraction for mating become the cause of their despair. That is the vulnerability. Most parents know that, that is why they do not want you to do dating, they do not want you to do this or that, listen to them, but we think we know more than them, and we tell the hell with you. Either you are going to keep on lying to your parents, or you are not going to tell anything. But then when you become parent, then you realize the mistake, but by that time it is too late, and the story continues. You used to call your parents, you are backdated people, you do not know, your kids will tell you exactly same thing. Just wait for that to happen. So, anybody has any question, because we are going to build everything on these two terms, weaknesses and vulnerabilities. And then we are going to talk about different types of attacks, software, firmware, hardware. That is what is today is the first hour. Now, the best way to, when we write proposals, we always have to tell why funding agency will give you money, you have to tell what it is, or you have to point them to the news and the, okay, this happened. Anybody knows this particular news? It is from last year, controlling a car by a license plate. Anybody knows why that is possible? Because cars are designed, any car that you are driving today, that has been planned about 20 or 15 years ago, that got government approval, then they got manufactured, they came to the dealership, you bought it, unless you have a habit of driving brand new car, it's going to get older. 10-20 years later you are going to sell it, somebody else driving it. Car has a long lifetime. Even if you design a security, that security would be like anybody can break it, even the baby not born yet, they can break that security. So, that is why it is so easy for the car. And as you go along, you will see many of those whatever news you see, you will be able to make sense out of it, and why it is so much easy. The world actually is friendly for attackers, world is not friendly for good people, it is friendly for attackers, liar, cheat, fraud, and I hate them, all of them, because that is exactly what they do. Politicians, they are the biggest fraud in the world. Religious leaders, gurus, they are the biggest fraud in the world. They play with your common weakness, and we are going to enumerate them. It's pure science. It's just that science I learned now. These science they know for eternity. All these people who can see your hand, put something on your hair, put bunch of rings. I just put that ring when my father passed away in honor of him. Putting all these rings and all that stuff, it's just a way to extract money from you, controlling your mind. That's the basically game. You respect somebody, that's wonderful, but in return of that respect or whatever you put on, you are going to get some miraculous stuff. That's bogus. That's basically this stuff. Basically you are letting you. And when you think of anything I teach, you will be thinking of human body as a computing device. If I can walk next to you, if I poke you, if I see how you react, I know how irritable you are. Those are your side channels. That is exactly the scam artists do. They try to figure it out and then play with your weakness. So, when you think of computing devices, depending on which layer we talk about, different types of weaknesses and vulnerabilities are there. In these basically 10 days, we are primarily going to stay at the system level for most of it. I have one day on network related security, but most other day it's at the hardware software level, and one day about architectural Spectre meltdown. We are not talking about here. That does not mean we do not have a problem. Actually, if you see the spectrum, the actually attacks and all that research, that is actually much bigger space I am not talking about. So, if any of you are from devices kind of background, then you might be thinking, well, this is not covered, because there are so many. For each type of technology there are different vulnerability. I will be happy to talk about them, but we will be covering in this space. Any of you have any questions about the scope of what we are going to cover? System level security or at most hardware architectural level security. But before we talk about security, I want to dispel one confusion. When you do banking transaction is going fine. When you type anything or you enter your credit card information, what do you see in that line in your browser? Can anybody help me here? In your browser, whether it's that's the pen? Now? Oh, pen, I have to. Okay, so when you have your browser, whether Firefox, whatever you use, when you type HTTP and all that stuff, what do we pay attention to when you are doing credit card transaction? We look for a character. What character is it? S, right? Anybody knows what that S stands for? Secure shell, right? Security. That is what the security in this context. If the word S is not there, you won't be comfortable entering your credit card information, right? Anybody knows what does that S do? What's the magic? Or in your Linux shell when you do SSH, or anywhere when you open a virtual private network, all of them are same idea. What do you think it does in layman terms? In this class, everything will talk in layman terms. We won't get into buzzwords. What does it do? It does tunneling, right? It creates a, so if this is you and if this is I, and it could be bank, it could be you, but it creates a tunnel, some kind of secure tunnel where once you put the information in, this information goes here, nobody else can do anything on this side, that side, here, there. So, it is create a secure tunnel in some form. So, if secure tunnel is there, even before I am presenting this talk or you are listening to it, if it is working, when you are doing secure banking transaction, when was your credit card got stolen? Never. Or that information is not there. People steal information break, that we will talk about. So, if everything whole world is perfect, why are we creating this fake GIAN course to talk about all this stuff? Why? How do I erase this text? Pen again? Oh. Okay, let us touch it. Anybody knows why are we then talking about it? If everything is working fine, why do we need to talk about it? We need to talk about it because everything is actually not fine. It just, there is an animal called possum, and when anybody attacks possum, it puts, it either closes its eye, or if there is a sand or something, it hides its face. So, the idea of the possum is if I cannot see my attacker, probably my attacker cannot see me. That is the idea, because we do not know. So, this is a limit of stupidity, and that is basically I am trying to cover in this slide. Lot of information, but the key idea is that what we have, and that is I kept for one of the day, what we have is known as trusted execution environment or security enclave. So, if you are from computer architecture background, you know that you have, so if you have 2 cores, 2 core, 4 core, does not matter, let us say, let us put 4 core, 4 processor core doing some application and some memory. So, this is core 1, core 2, core 3, core 4, and you have some memory. Then what, whether Intel SGX, AMD SEV, ARM Trust Zone, whatever those basic membrane that provides you security, it basically provides you a security enclave, little part of memory, and 1 core or some percent, actually statistically it is about 10% of the computing ability, it puts a tunnel around. To give you a tunnel, it also needs a secure tunnel, because the person who is digging the tunnel, if that person itself is vulnerable, then if your bodyguard's body is not stable, how can a bodyguard will protect your body? So, then that tunnel is just one of the core and little bit of memory, that is kind of secured from other. So, some program running on there, some program P1, another program P2, all these programs running, anything you are running, for example, this secure cell or VPN, whatever you are trying to run, anything happening here, other programs running in other core, although they are sharing some of the common devices, buses, networks, they should not be able to get a smell of it. That is the whole idea. Now, here are 2 problems with this idea. So, I want to show you the fundamentals itself are flawed. That is why the whole world is attacker's paradise. That is why gurus are doing so much of business. We are working hard, we do not have food to eat. The people who do nothing other than scamming, they have so much money. That is why people do not run to see a Nobel laureate or educated people when they go to their villages. Nobody ever came to see me. But if some idiot politician leader comes even remotely close to my village, thousands and millions of people will flock to meet them. So, that is fundamental flawed philosophy in society, is fundamental philosophy of what we believe is right, that itself is wrong. So, now if you think, go one more step below, let us assume that 10% of the cores that are secured is actually secure. First of all, that is also wrong. Let us assume that. Still 90% of the cores and memory, they are not protected. What will happen to them? All these ministers have bodyguards, we do not have any bodyguards. If somehow human values are not good enough, which is good in India, many other, you go to Brazil, people either have bulletproof door or they do not go to the street. You may not believe me, just go. If you come back, you may not come back to have this conversation. In many of these top cities, that is a serious problem, right? Because majority of the people are just out there to steal, and it is okay, that is the common concept. In fact, if you are stolen, people will not say sorry, people will say, what kind of person you did not go protection and went out to the street? right. So, it is a different culture, different philosophy. So, this 90% is we have a serious problem. Now, that is about them, but even 10% as we go along these 10-11 days, Professor Karfa will show from software perspective or compiler perspective, I will show from other perspective. Even there are published literature to show even this is under tremendous attack. And one of the attack conceptually I can explain you that the idea of security enclave is either you are my friend or you are my enemy, the typical dictatorial philosophy. Either you listen to me, work with me, either you are with me or you are against me, that is the security enclave idea. The programs that is running within security enclave, they can trust each other, but they do not talk to the people outside the security enclave, like rich people do not talk to the poor people. But the thing is that what attackers do, that the things that are inside the security enclave, this processor, memory, the attacker actually pretend that I am your friend. They do many ways, again 10 days we will go through that. One of the way is just getting your login and password, and then I become part of it. But there are many other mechanisms to become part of that cult, like the spy of Indian spy in USA, US spy in India, that is what they do. I guess all of you are adults, when people sleep with each other, that is how they get information out. In fact, in American system, most of the security clearances, if you slept with somebody more than once, then you have to report it, otherwise that is a federal crime. It may seem so funny and vulgar, but that is the laws are, that is how laws are, otherwise your security clearance would be revoked if you do not do that. So, the idea is that either you are in or you are out, attacker actually takes advantage of it, like the idea of honey trap and bribing and all that stuff. You are getting information from this security enclave. So, even this 10% is not secure, even your HTTPS is not secure. Then you may wonder, how come then when I do transaction things are going fine? Maybe that is a lucky day, you wake up on the right side of the bed, you do not have that much of money. In USA, if you hit somebody, some people will jump in front of your car. If you hit somebody, that person is going to make millions and millions of dollars just by being hit once. The way it works, again it is all scam. The way it works, you go to a lawyer and you say, okay, this person hit me and I think I am dead, right. Then the lawyer first thing checks how much money the person who hit you has, and then say, okay, I will do it for free, whatever we get, you 50%, I 50%. That is how it works. If you do not have any money, the lawyer has no motivation to take that case, and they will pretty much extract all the money, because there are doctors who will certify you are mentally retarded for rest of your life. They do not believe you can lead a normal life, and somehow they think you would have got a Nobel Prize, and that Nobel Prize would have got converted to some billions of startups, and it would have loss of billions of dollars for that person. Therefore, that person deserves at least $100 million in restitution and damages. So, it is complete scam, whole world is a complete scam, and all the advantages and laws in the name of victim are on that side. Any questions? Right. So, now that my whole idea of this discussion is to dispel the idea that things are secure, and therefore, we do not have to worry about it at all. Things are not secure, nothing is secure. Only reason nobody is attacking, they have no motivation, to attack you. It is not enough investment for them. What did I do?
Previous.
Oh, I will do previous. Any question on this? This erase somehow. Anybody has any question on this environment or the key idea, how all of this works? So, throughout these 10 days, I am trying to zoom into each of them and talk about who is. So, for subsequent days, we will assume this 10% actually works, which I am saying now that actually does not work. 10% works. How is it working? What components are working? Then we will attack at the component level. But I wanted to give you the big picture where all of it is heading. I saw a hand somewhere. Yes, please. Oh, no, HTTP doesn't have its own Trojan. I can please it. HTTP doesn't have its Trojan. If you can have a Trojan, that's a different problem. HTTPS is implemented correctly, but it's just that the implementation itself has vulnerability. So, we will talk about on the cryptographic days I was planning to talk about it. Cryptographic algorithms have mathematical guarantees that even if you spend all the lifetime of the universe, you will not be able to break it. But when you implement it, some of those guarantees are gone. So, some of the guarantees relies on variables with infinite precision, but when you implement a variable, it is a 32-bit number, it is not infinite precision anymore. Or when you write a if statement, if A greater than B and A and B happens to be a floating point number, one is becoming 14.999, another is becoming 15.0, then suddenly greater than less than equality becomes a problem. Even if numbers are equal, they may become a greater than or less than. Branch condition check, branch prediction, all those issues creates the vulnerability, and that becomes a problem. So, HTTPS implementation does not have any problem. That is why I will zoom into each of the component to show you the vulnerability. That is why I started with the example of sainthood. If we can get rid of all the weaknesses of normal human things, it is just that we know the weaknesses. Throughout this 10 days I will show you most of the attacks in computer systems are based on top 5 or 6 common known weaknesses. Most common weaknesses people know. Most people die because of overeating, less people die because of hunger. But we know that eating food and eating junk, oily food, greasy food, we know that, but we still eat that. We still eat that. Yes, please.
Sir, like you just explained the concept of security enclave, and it seems common with a lot of things such as the firewall or the VPN, all are based on that concept.
Same idea. It built on that security guarantee.
Different paradigm of security than the security enclave.
No, all of those guarantees you talked about, they are built on this root of trust, and root of trust is basically the security guarantee.
There is no alternative.
No, there are no alternative. This is the architectural level guarantee you provide, and then everything SSN, VPN, SSH, anything you built on top of it, that is basically something user friendly idea, right. The analogy you can think of, most of our parents, or at least my parents taught, do not trust the strangers. Nobody told us be careful about your friends and the people inside the house. When you enter the house, you feel secure. That is the biggest danger. If you look at the statistics of rape, murder, all that, 70% of them are done by relatives, close friends, the people you know. Nobody taught us that actually be more careful about the people you know than the strangers, because when you go out, your antenna goes on, you try to be careful. When you are inside your house, you are relaxed, all your guards are down, that is when attacker attacks. So, it is all of them based on trust, and throughout these 10 days we will be trying to tell, actually your question is very interesting, we will be trying to show you that root of trust is actually not trustworthy. Even our antennas should be on even when you are at home. You should not trust even the people you know. Now, how the landscape is changing, I want to show you why it has become more and more attacker friendly. When I was doing PhD 30 years ago, it used to be kind of general purpose systems and then moving into slowly embedded devices. And now general purpose systems nobody care, IBM sold off their business and Lenovo bought it, you know all that story. So, now then it is kind of, then even embedded systems kind of became IoT, and that has all kind of challenges that is attacker friendly. I want to just touch upon one or two why all these IoTs and smart house. So, it is all friendly feature, most of people ask for it. When I bought my house 10 or 15 years ago, I did not even have a choice, do I need home automation or not, it comes with that, you can't get rid of it. So, which is a good part, even with my phone I can open my front door. Being in India, somebody coming to my house, my friend, and I just click a button right here, those of you would be interested, I will be happy to demonstrate you. But a door will open. Now, if somebody can hack into my phone, they do not need a key, they can open my door, get in, steal whatever they want, they can control everything there. When I bought the TV, I didn't know my TV is recording me. A TV is supposed to show me something. It's not supposed to take my picture and do all that stuff, whatever it's doing, right. So, this automation is great, user friendly, but it comes with that. So, the thing is, the objective of a cyber security researcher is how do we minimize vulnerability of diverse complex computing systems to malicious attacks. And any of these devices, no matter how small and cool and friendly they look, they have billions of transistors, millions of lines of code. As you go along, you will see, forget about millions, even verifying 10 lines of code that there is no vulnerability is a difficult proposition. I downloaded a calculator because he didn't like the original calculator I came with in the app, and in the installation process it asked me, do you want the calculator to access your contacts? And I was scratching my head, what the calculator has to do with my contacts? Then something occurred to me, and my phone has no more apps, or at least the apps that I can delete. The system does not allow me. That if somebody has the audacity to ask me, can I access your contact, it probably accessed my contacts already. So, the idea is the complexity and the stuff going on, most of us do not know, most of us do not care, and that is where all these problems starts. And then things become complicated if you think of, so this is, I think the Dresden is the first country where everything got connected. So, I mean, sometimes in many advanced countries that is there, many city decided all the buses runs through, you can download an app and then it will show you which bus is here, it is all friendly. So that when you are standing in the bus stop, you know which bus is coming where, when you are connecting multiple buses, it is everything all known, real time, not the fixed posted schedule, real time you exactly know which bus, which train, where is where. But the problem is, if an attacker can break one of the link, then it basically it can put the whole city into shutdown mode. So, you get certain advantage then, but when there is a connectivity it becomes problem. So, as I go along, I will show just one more slide. 30 years ago, any product you design 3 to 4 years. So, verification was 1 year time. Now today everything is less than a year. iPhone when get released every year. So, every design has exactly 1 year, and things are like 1,000 times, million times more complex, billions of security vulnerabilities, nobody has time to verify, and then basically you have all these problems plus you have no time to verify. So, that is why it is an attacker's paradise, that is why we see all these problems. Now, if I keep saying this, you might be thinking, okay, I know there is so much problem, how does it help me, can I solve it? You can't solve it. The way it helps, if you can lock your car in your parking lot, you are already doing a great stuff, because there are idiots out there, they will not lock their door, and unless the thief is also idiot, which is most of the time that is the case, nobody will try to break into car if there are a bunch of car doors that are already open. Or if you have IoT devices in your house, it comes with factory default password, which I can break even sitting here. That is illegal, but I can still do it. So, nobody even bothers when you get a router or whatever for your house, nobody even bothers to change that factory default password. First of all, it is not the same password for every device, but I kind of know how those factory default passwords are generated. I know they are unique number, but I know how they get generated. But if you create your own password, that is difficult for me to guess unless I have already known 1 or 2 of your passwords. So, one cybersecurity expert from IIT Kharagpur was sitting next to me, we are going for VLSI design conference. So, I basically said, I can break into anybody's phone. He said, there is no way, here is my phone. So, I just looked at him, by the time I smiled, I broke into his phone and opened and gave it to him. And of course, you can guess who this professor is, but the thing is, professor said, how did you do it? I said, there is a basic rule in magic, you never say it. Because even if I say it, your inquisitiveness will not end, it will only increase. No, I do not believe that, I am not going to ask you any more question. I said, promise? The person said, pinky promise, that promise. I said, okay, just turn the phone little bit towards the light angle and it will show you the oily change of whatever pattern you created. I just looked at, I twisted, looked at that pattern, I just did the slide. I had to try twice or thrice by the time I smiled, because I did not know whether you tried this way or that way, I had to just figure that out. Oh, I could have cleaned that surface and gave it to you then. I said, you promised me you will not ask me the next question. So, because even if I explain that how that would be broken, oh then if I do that, it does not matter, it does not matter, it is attacker's paradise. Any question so far? Now, so to add to that complexity, there are fake devices, that is also attacker friendly, and these are from my sponsor. So, this is a genuine versus fake Canon whatever thing, and it is very difficult to figure out which one is genuine and which one is fake. It pretty much looks the same, and this is genuine versus fake Cisco router. Actually the fake one actually looks much better, because some of the printing was very nicely done, and in the genuine one there are some discontinuity. And then this is from the genuine from Honda car, they are basically the PCB, the main motherboard controller. So, pretty much every device you are carrying, it has fake stuff. So, it should not be a surprise to you that Israel is able to so peacefully pull that pager attack. It is pretty much everything you use, it has stuff, it just nobody is pulling the trigger off, because you are not worth their time and effort and legality and hassle. But if you become famous, if you have lot of money, be careful, you will be under attack. So, I can go on and on and on, but now I want to go to the fundamentals of weaknesses and vulnerability. That is where I have started. Security research, if you want to start, this is where you start. I have one problem, whenever I talk about something or somebody, I talk very highly, as if whole world is about security. In the after lunch, when I talk about explainable AI, I will give you a feeling, do not work in any other domain, explainable AI is the only thing. So, you have to forgive me for that, because if I marry somebody, I have to say, do not tell this to my wife, I have to say she is beautiful, that is the ground truth. So, anything, that is one way to look at. Second thing is, I cannot do research, invest time and energy if I do not feel strongly about it. You have two ways of going about it. I am working in this area, or wow, I am working in this area. Fooling yourself is not cheating, fooling somebody else is bad. I can fool my mind. Happiness is a state of the mind. Being happy does not need even a single paisa. You do not need money to be happy. In fact, converse is actually not true, it is actually dangerous. But so, let us get into these weaknesses and vulnerabilities, and let us see it got from here. The way you want to start security research is basically by going through, I will zoom into this. There are websites maintained by US National Institute of Standard and Technology in collaboration with Mishra Corporation, and they maintained all the weaknesses and vulnerabilities known as of today. If today you do a research, find a vulnerability, there is a reporting mechanism, I will briefly walk through, and then it would be catalogued. If you publish a paper, it would be catalogued. If there is a security vulnerability somebody found and you found a defense for it, that would be catalogued. So, right way to start. When I started on research, I did not know this is the place to start, because I realized my mistake. That is why the first lecture I am telling you, this is where to start. First you figure out what research you are doing, you go there. So, the firmware itself has 6,000 vulnerabilities. So, there are 6,000 attacks has been reported on firmware, and most of you probably never seen or touched a firmware. Maybe this is the first time in this lecture you will zoom into it. So, such an unknown thing has 6,000 known different types of vulnerabilities. And then here I am showing some data set. You can generate any kind of picture or out of it, that how many software only. I am only looking at electronic system vulnerability. If you are looking at mechanical and all that stuff, airplane and different other parts, sensor and all that, then there would be more. So, in that you are kind of looking at, in this talk we are primarily focusing on hardware plus software kind of thing in this talk, but no matter how you look at it, different types of weaknesses it is kind of looking at and then creating vulnerability. But so, as I said, there are two web pages. One is let me see, did I give the web pages to you? No, one is, let me write it down, I thought I did. So, there are two kind of weakness, the two web pages, that is important. One is HTTPS and all that stuff, one is common weakness enumeration.org, that is the list of all the weaknesses, and that is where you want to start. And then common vulnerability enumeration.org. If you want to be a saint, we exactly know what are those 5 or 6 the weaknesses normal human being have, you exactly know 5 or 6. But here the list is little longer. I remember, I do not think it is 5 or 6, I think it is 500, 600, but that is a still small number. And as I said, most of the vulnerabilities, hundreds of thousands of vulnerabilities are based on, again it is in the order of tens or order of hundreds, but most of the vulnerabilities are that like top 5 to 10 vulnerability. If electronic systems you can design and those vulnerabilities are not there, that is pretty reliable and stable electronic system. Same human being, those 5 whatever, anger and greed and whatever you guys know, right, those common 5 things, all those 5 things you get rid of, there may be other things, it is okay, it is not a problem. You are not open to attack by scammers. It is good for you, good for your health. You will live longer, live younger, live happier, you do not have to see a doctor or psychiatrist. Any question on this? Because these two are very important website. Of course, there are other companies maintaining it also. As far as I know, there is US government also has a national vulnerability database. I am pretty sure every country, even India might have such thing, ISEA might have maintained some websites, does not matter, but that is the starting point. Any website you want to go, that is the starting point, instead of start reading random papers. Yes, please.
What is the difference between weaknesses and vulnerability?
Yes, so the weaknesses and vulnerability. So I enjoy food. In the lunch time, you will figure out if you have, I enjoy food. I do not eat too much, but just I enjoy it, love it, right. And if my attacker knows that I have that vulnerability, that I have affinity or weakness towards food, then basically they will do a poisoning attack on me. If they want to kill me, then they will invite me for a nice dinner, lunch, coffee, whatever, and then they will basically put poison on it. So putting poison or trying to kill me, that is the vulnerability or successful. And in the security domain, weakness and vulnerability, that is the difference. Weakness is there is something we are doing that is open to attack, but nobody attacked yet, right. So but the vulnerability, somebody actually used it to mount an attack, that is the distinction. And the example of a bird I took, that bird basically has affinity to mate with a so this is basically male bird who basically hides, very rare to find, and then basically playing that whistle, that weakness is it thinks there is a mate available, let me try my chance, and will come out from hiding to the open field, and when hunter will shoot, when hunter shoots, that is a vulnerability for that bird. But the idea that the whistle with that sound as if some female is calling him, that is the weakness. If the bird did not have a weakness, it will never come out to open. What do you think? The very idea, instinct that it is hiding, it knows that if I go out, some hunter will hit me, hunter or some tiger or somebody will kill me, it knows that. But on that weakness moment, people lose all their senses. Okay, any questions, more question on CW or CR? Those two websites would be a good starting point, very good starting point. Yes, please.
Sir, when you're talking about weaknesses, are we just talking about machine level weaknesses, or just the thing that we're talking about, the human mind weakness?
No, human mind I am just taking as an analogy. In this class, I am not talking about any human mind. I am just connecting so that it is easier to understand. I am only talking about computer system weaknesses in this class, specifically electronic system, software, firmware and hardware. Those three things we are going to focus. We are not going devices level, we are not talking about politicians and all that stuff. That might be a different thing, different days, and I am not an official expert on those. I am a victim of those stuff. Okay, so now weakness is the most important thing, but then the common vulnerability, cv.org, so basically it enables people to have a same conversation, because it got categorized. When you say vulnerability, side channel attack and all that stuff, everybody in the world knows what does that mean. Because of this website exists and categorization, everybody talks in the same language, and it basically if you want to report whatever vulnerability you find, this is the kind of step you take. You discover some vulnerability when you are doing research, you make an attack and say, wow, I am able to break into this device. Of course, you first go to that website, you see if somebody else also attacked or found similar stuff. If not, you report to this company, and then you may kind of request them that oh, give me a CV number, they check it, and there is a long process. That is one way. Or whoever device you are able to break, let us say some smart thermostat, smart bulb, something you are able to attack, let us say it is manufactured by Sony, you contact the Sony cybersecurity department, and then they either come back, they will come back. These days people are serious about it, because I remember one of the company, I think Nest thermostat used to have biggest market share. One of my colleague Eargene found the vulnerability, reported them, they never got back, and he went and published, and basically that company pretty much, I do not know whether it exists now, they are gone pretty much in the eternity. Now most companies have at least 1 or 2, 3 security people dedicated who will look at what vulnerability you found, then they will probably request you give us 6 months or 1 year, do not publish, and we will try. Then once they validate and return back to you, you can publish, and they will also report to CV and the category will be created, but whichever way. And if you are a researcher or professor, these days publishing in top places, security places, NDSS, CCS, Usenix, they kind of expect you found some vulnerability and CV got created. If not, does not matter what you have, they will reject it. So I am not supportive of that idea, but somehow it kind of assumed if you say you found you are able to attack something, then how come there is not a CV against it? Why did not take that extra step? You did so much of work and spent 6 months, 1 year doing the research, why did not you take those extra time to create the CV and get it out of the system? Now what I wanted to show you now, for any device, all human being, most secure and protected device is your smartphone. We can offline talk how unsmart is to carry a smartphone. You are near and dear and one can track you. If you are going, drinking, boozing, gambling, whatever, they can trace you. And because near and dear one is probably not your attacker, an attacker can track you too. And of course, most of the guys put their phone on their pocket. And then if you are young enough, you may not be able to produce a baby, take it from me. The amount of radiation, companies will always tell you is not healthy enough, it is not. If you put next to your head and sleep, you will go crazy soon. Now most of the research has not been done, and if 30-40 years later research is done, you cannot go back in time and move that smartphone away from you. But that is a different discussion. Today's discussion is even that smartphone, which is the most secure device for any normal people like us, if people from defense and all that, they might interact a lot more secure devices than this. For us, this is the most secure device. I want to show you how unsecure it is. Depending on what level access I have to your phone, whether you are downloading my app or whether your without your permission, your machine learning tool is downloading a model or upgrading its model from the cloud, or whatever happens, each of this place, even the idea that your device has some debug port and you can access those debug ports, even that is a mount to attack, and we will talk about that zoom in. Cloud access, sometimes you access knowingly, you go to your Google Drive and all that stuff, and everybody will tell you they are secure. Cloud will say they are secure. Communication, your Verizon, AT&T, whatever services you use for communication, Jio, Airtel, whatever, they will say they are secure. You might be saying, if everybody is secure, how come this is happening? And that is a common human psychology. I am not making it dramatic like Bollywood movie. I never had a tea, I never did this, I never did that, how come this happened to me? I heard this like millions of times. Where is it written in religious scripture that life is fair or world is fair? Where is it written? Show it to me. Nowhere it is written. So that basically means that all of this stuff everybody calling secure, they actually do not know what they are talking about. They have no idea. And basically that causes problem. Even the idea, now networking level, I have one day because of dole or whatever break Dr. Karfa will talk about, I do not know whether I will get time, then I will talk about even the knowledge of this, you can mount lot of attacks. Even as silly as how much battery is left on your device, I can mount certain type of attack, just knowing how much battery is left on your device. Any information can be used against you, any information. In fact, US has something called Miranda law. Anytime anybody arrests somebody, first thing the cop will say, you have right to remain silent, anything you say will be used against you. Unlike in India, they will harass, torture, extort, make you sign on some form. So, any information I can get from your device, it can be used to attack. How much successful? Do I need little more information, less information? But I am just trying to show you, even the smartest device that each of us hold, most secure device, is utterly insecure. Utterly insecure. Not using it would be the smartest choice you can make. Any questions? Now I am going to take few example of different types of attack, just to give kind of close this discussion. Software level attack, and we have days dedicated for this. There are whole day dedicated for just for malware. Malware basically stands for malicious software, it is abbreviation malware, and then there are tons of them. Most of you probably more famous with ransomware, that is a class of malware, ransomware attack, and they will lock your file, then ask for payment in cryptocurrency, otherwise they will not unlock, and if you did not get a ransomware attack, that basically means you are not rich enough. Either you are not rich enough or somehow you are good to hide how rich you are. Biggest mistake people do is wear expensive clothes and show off to the people. This is a bad idea. Actually, more rich you are, you try to show you are extremely poor. Nobody would be interested, people would be sniffing at, feel sorry for you, stay away from you. From a cybersecurity perspective, that is a great idea, to be humble. Actually, that is a good thing from a religious scripture also. Being humble, being respectful, being poor. Donating all your money would be the ideal thing, but some people cannot handle money. But because of that, it is not surprise 70% of organizations experience type ransomware attack, they paid ransom, some of them report, lot of data. We will zoom through this, we will zoom into this on the day on ransomware. There are different types of malware, we will basically talk about those, and if any of you are interested, we will play those ransomware from my computer to your computer, just to get just for fun, how to get everything from your laptop into my laptop. But I need your explicit permission on a piece of paper, you are not going to sue me, just to show you how much easy it is. I do not even have to fold my shirt, and just piece of cake. Anything you have, if I can do it, anybody can do it. So that is why hiding information is a bad idea. If you want to hide information, put it in the broad daylight, nobody would be interested in that to know. If you have a girlfriend, say it boldly, your parents would not be interested. If you are doing hush push, you are in trouble. Okay, so this one is my favorite one, this is one of the ransomware, and this attack and hundreds of millions ransom later, it turned out that US National Security Agency knew about this vulnerability. So, Windows operating system had a vulnerability, these attackers from Russia used that vulnerability to mount the attack, and they extracted hundreds of millions of dollars. Later it turned out National Security Agency knew about it. Now my question to you is, if US National Security Agency knew about this vulnerability, why didn't they inform Microsoft or Bill Gates to fix this vulnerability and waited for Russia to exploit this vulnerability, mount the attack, and took a tons of money from 3 school districts and 1 bank, I do not know, 100 million, 1 billion, I do not care. Why did you think National Security Agency did not tell Microsoft that there is a vulnerability? Yes, please.
They have their own vested interest in it.
They have their vested interest. In fact, later it was published, National Security Agency was using that vulnerability for spying on US citizens, that is the part freaked everybody, as well as people in other countries. Everybody was using Windows operating system those days. It was from vulnerability was there from 2010 to 2017. They were using it for spying on everybody, on everybody. One day I became crazy. I was looking at my Dell system, Dell computer. I tried to go chip by chip what it's doing. There are like 5 or 3 chips I couldn't figure out. Nobody knows. So after pager attack, everybody got surprised. I didn't get. There are bunch of chips somebody is inserting somewhere in the supply chain, and nobody knows. Nobody knows, including Dell. They don't know where those came from, and pretty much your computer will have same thing too. I don't think I am that famous or important just to have an individual, and every computer has that stuff, just logging data, transmitting data. Firmware attack. Now this is the first time I am going to introduce you to firmware. How many of you know firmware or played with it or seen how it looks? Black or white or brown or yellow? None of you? Okay, so first of all, we still have systems, so the C for the thing. Let me just zoom on to car. All of you will be able to relate to it. In a car, if I zoom in, you will have lot of module. Probably the cruise controller would be the one you would be able to relate more. So you basically set your cruise, and whatever speed you are in, it will try to maintain that speed. The word adaptive will say if it's a upslope, maybe it has to increase its fuel injection to maintain the speed. If it's a downslope, it has to reduce. While it's doing it, there is a car comes in front of it, it has to slow down because you requested maintain a cruising speed of 80 km per hour. It would probably not do that because your safety is important. That's why it will slow down. So if I zoom into this cruise controller, so then basically you will see what is happening. So you have sensors and actuators. Sensors are basically going to measure distance between the car, current speed, and braking distance, and then firmware will convey that information to operating system. Then some applications running, that's basically figuring out all this stuff, and then information percolates through, and then braking action will happen if needed. Either fuel injection would be reduced, that's also actuation. So this whole sensing, actuation, data getting transferred between application through operating, that's the firmware. If in layman terms, firmware is nothing but software. It is written in one of the programming languages. It could be little proprietary language, but it's still like C, Java, whatever it is. But it's just that the way they are written, the way they are maintained is slightly different. Those of you know the whole manufacturing process. Most of you, those who work in application, you don't care about anything because you assume operating system is completely reliable, it will take care of it. As we go along, we'll figure out that's not true. The person who is supposed to protect you, that person itself is vulnerable. So then firmware, there are different ways of thinking. Think of a BIOS. When a computer is manufactured, inside the way you have processor memory, little bit of program, compiled program also get manufactured right then and there and sealed. You can't do hanky panky with it. So whenever you install operating system first time, then that operating BIOS will check, is it a legitimate operating system or an attacker trying to fake as I am from company, all these signature check, all that check, that's what BIOS does with the help of the hardware, the tiny thing that got installed. So it's slightly, it's a software, but it's the way it's managed, and then when you want to change the BIOS, that's even more interesting. You are like checking about yourself. It's like I was a bad person, today I decided to become a good person. So you decided you want to be a good person, you know you are a bad person. Now the behavior you are picking up, you are checking, are those behavior good enough? Should I eat less sugar, less sweets? So this BIOS itself will check the new BIOS update coming in, is it legitimate or somebody faking, trying to get access? So there is all these stuff, and the day I talk about firmware security, I will zoom in. So that way firmware, the way it's designed, the way it kept, the way it managed, the way it updated, it's all different from typical software. So firmware, because of the name, don't think it's like little farm, not soft, not hard, little farm. It's not that. And many times when you have a hardware bug, you can't modify hardware. So, then you do firmware changes in firmware, so that either you can fix the bug or hide that bug, that is called firmware patching, right. When there is a new security vulnerability, you will get auto update, oh there is a security update needed, that is actually a firmware upgrade most of the time. Sometimes that could be operating system upgrade too. Any questions? Yes, please. Sorry, can you little louder please?
If we have a system and we put some firmware module in it at the place of some hardware module, can it work?
So, you are saying, so first of all I did not show the hardware here, you are saying instead of a hardware block, can I put a firmware block?
Yeah, at the place of that hardware module. If we have required,
We can always do that. In fact, you can have whole system, in today the speed of processor is so much, you can have whole system running only on software, you still be able to maintain your real time. In fact, many embedded devices you do not have operating system.
so sir, which one will be more vulnerable to security threats?
So, hardware is less vulnerable than firmware, software is most vulnerable.
So why we prioritize than firmware if it is more vulnerable?
We do not prioritize firmware, it is a flexibility. Hardware is impossible to change or modify after I sold and it is in the deployment. Software is very easy and flexible, firmware is in the middle. The idea of firmware is basically think of something between software and hardware in terms of flexibility, modifiability and all kind of guarantees, it is somewhere in the middle. And again wait for the firmware day to get into the zoom. Now finally the hardware attack, basically we are going to talk about system on chip. So, in the days 20-30 years ago 1990s, if we used to have all these big computer, you open it up, there is something called motherboard and you have everything on top of that printed circuit board known as motherboard. You have processor, you have memory, controller and all that. Today all of those motherboard got shrink into one integrated circuit, that is all is known as system on chip. Yes, please.
So nowadays like mobiles or laptops, they give 2-year or 3-year software updates. After the beyond that they do not give. So what is the reason behind? Beyond that, is there a chance that they can be hacked or?
So, very interesting question. Most companies give 2-3 year upgrade and unless you buy. In fact, even if you want to do no matter what, even companies like Apple, they charge so much premium, after 6 or 7 years they do not give any upgrade. So, basically they want you to buy a new phone. It is in their business model, it does not make sense to support so many versions of operating system, that is one way to think about it. And some phones are so reliable, it may last for 10-15 years. How are they going to give $500 million salary to their big CEOs and all that? It is not possible. Their profit sharing, stock and all that. So, they want you to get rid of your phone as soon as possible. So, that is the business model side. Other side is it is very impossible to maintain so many versions of the phone in so many markets, so many operating systems, so many firmware, it becomes impossible for them. They have limited number of groups developing those patches. Now, each of the patch modification they have to test on all these computers, all these phone setups. It becomes unmanageable. So, somebody in the company made that decision. That is the 3-year decision. And the basic premise I want to break, even for those 3 years you are not protected. I want you to know that and believe it. You are thinking after 3rd year I am not, my phone is not protected, even those 3 years it is not protected. Very simple way to prove that is that when a patch comes in, that means they know there is a vulnerability and most of the time it is not identified by that company, some other company, some other hacker, CV got created, then they developed the patch. So, there was this window of opportunity when attacker attacked it, when they put the patch in, that time anything can happen and you won't know you were attacked until long time later and it is too late anyway. So, these IP and Dr. Karfa is also talking about it, and this I am going to zoom in later, it is already 12:30. So, I am going to just fast forward. One thing I want to tell you, even the system on chip, which is I am going to discuss in this lecture, was in this technology of 1970. I am one of the contributor of Semiconductor Research Corporation Electronic Advanced Packaging Roadmap, what is going to happen in the future. It is a 1970 and when I am writing, contributing to this and developing this, I realized and I got confused really. So, we have serious problem with 1970s technology. Now think of what's happening today, heterogeneous integration from multiple fab, the vulnerabilities are just numerous, attacker's paradise. And we are going to talk about lot of types of attack. One of the day is dedicated for hardware Trojan, and other stuff also I will talk the day we talk about hardware security related problems. And even if you can zoom in and one of the chip says the name of that chip, he says trust me, don't. So that is basically the conclusion. So basically there are lot of security vulnerabilities. So whether the software, hardware, firmware, there are application specific attacks, and so then in the afternoon we are going to talk about how do we use machine learning to kind of defend against attack. But before I talk about how we can defend, we will zoom into whole afternoon is dedicated to zoom into machine learning. So I will start with very basic, like going back 30-40 years at the beginning of the machine learning. What are those stuff in layman terms, how does it work, and I am not going to get into this probability statistics, although that is the base of machine learning. I will not get into, I will not even put a single equation. I will build that. Once we have that background, then I will build on top of it. So how machine learning is basically different names, zero shot learning, reinforcement learning, adversarial learning. What are these buzzwords mean? Once those are covered, then I will get it about explainability. So explainability will come, and when that is done, then in the afternoon I am done with explainable AI. Thank you. Have a wonderful lunch.
So we are done with this session. Those came from outside. We have mess in hostels. You don't need to go to the hostel you are staying. You can go to the nearest one. Instead of piano mode, right? You can go by 56 rupees and you can pick. There are few canteen around this academic block. So this is the basically academic blocks, and there are many courses, and you have a canteen there, and there is a hashtag also outside. So you can, if you don't want to walk that far, so there are some options here also. This in the academic block. Okay. So we'll again come back here at 2 p.m. and we'll start the.
and here is a brief outline. So, I am going to introduce what AI or basic machine learning is. I am not going to assume that you have any background. How many of you have background in machine learning? How many of you can tell me what AI means, what those abbreviation means? Okay, that means everybody knows. Okay. So, then I am going to talk about some of the machine learning models, because these models I am going to use throughout this course to do different kind of cyber security detection. And then once we have some understanding, hopefully this would be before the tea break, and then after the tea break we will talk about explainable AI algorithms. So, the point to start machine learning is starting with programming. All of us, we know the programming, we write a program, smart computer, we write some program and then if give some input data, it produces something. If you are sorting if you are sorting algorithm, you are trying to sort, you write the algorithm, you give some data, it gives you a sorted list. Only thing is story gets little swapped in case of machine learning. You give the output, you give the data, it gives what program it was by. So, any machine learning algorithm, you give a set of data and then you ask or use it to kind of predict something, predict or regression, we will get into that. But basically you are trying to, from the data, you are trying to figure out certain behavior, characteristics, certain story, and then that program you are going to use, that model that is building, that model you are going to use, that program you are going to use for subsequent process. But starting point is output, starting point is, so this is basically the kind of story, it is just the story get little swapped. And before I go any further, I wanted to introduce few terms. Model, in case of machine learning we keep saying model. So, then what is the difference between machine learning itself and the model? So, basically once you give some data, the starting point always is data from somewhere, it depends on what context it is, and from that data the system learns something and it builds something internally. Whatever it learns or builds, that is what we call as a model. And once it builds while it is building a model, the notion of feature is that when it is building a model, it is trying to figure out what is important and what is not important, and that is basically a feature. For example, if you are giving a lot of data set with lot of fruits, apples, oranges and all that stuff. So, a typical feature would be like color, smell, taste, assuming your data set has that information. If you did not provide that information, then that is a different story, we will get to that later, but that is a feature. The people who are successful in this world, they actually do the right feature extraction. They spend their time very carefully. They do not waste their time in Facebook and all that nonsense. They invest their time very meaningfully on right things. It is not that they are spending 16-18 hours a day, they may be, but whatever the time is spent, they always calculate return on investment. That is the right feature. And why that feature important? Let us say for the sake of argument, color, the machine learning process, it did not use color as a feature. And then you are asking it a lot of questions to that model by giving lot of colorful fruits, all they look exactly the same, and showing images and then asking, tell me, is it apple, is it orange, is this, but it never learned the feature of color. Based on the color it cannot distinguish. So, that is of no use. So, right feature, whether it is learning by itself, we will talk about that, or you are telling it, helping it, please focus on the feature. When you are planning to find your life partner, everybody will tell you, all the elderly ones, do not focus on the look, focus on how good human being this, how much fraud this person is, focus on that. Is that fraudness matches with your fraudness? All of us are fraud, take it from me. It is just that what you think is right, the people who actually murder, they also have a philosophy, this person should have been killed, This person has a lot of money, that money should have been taken. I am Robin Hood, I will take that money, I will distribute in poor. Everybody has a justification philosophy why they do what they do. So, this feature is exactly that attribute, the quality, the values. When you find a life partner, what are these values that are kind of compatible with yours? Whether the kind of you see the comedy movie, whatever you do, that is the feature, that is the matching feature. Many of those matrimonial sites, they actually use that feature. Either they explicitly ask you, when you are wasting your time going through those clips in your whatever website you are doing those surfing, they actually very quickly figure out, based on which of the videos you are pausing longer, which of them you are going back seeing it very quickly. Within few minutes they will figure out exactly what you like, and it will make sure you waste your time there while somebody else is making money. Then there is a notion of label. So, when you are training in machine learning, there are two parts, we will get into that. One is training, which is right bottom, then you have prediction. So, when you build the machine learning model, you have to train it. If you never showed me any picture of an animal and then you ask me, tell me what animal it is, I do not even know what animal means, forget about distinguishing. So, during training time you teach, and during teaching each of the data you have to label, this is apple, this is orange. Then during testing time, this is the prediction time. Now you show another picture which is not the set of pictures you have shown, it is not the exact picture, maybe apple slightly smaller pictures, bigger aspect ratio or different type of apple. Maybe you have shown it a Kashmiri apple, now you are asking for a Fiji apple. It looks slightly different, but if it learn the right feature, it will be able to tell it is an apple, not an orange. That is the prediction it will be able to do. So, then these are the things. Now, label comes in the context. During training, when you are saying this picture is an apple, somebody gave you a set of data with bunch of images. Somebody has to manually go through and mark on them when it is training the data set. Here is a picture, it is an apple. Here is a picture, it is an orange. Here is a picture, it is a grape. Somebody has to do that. That is the labeling task. Now, do I need label and all that? There are different variations. Any of you have any question on these words? Because as I go along, I will be using these words comfortably. Model something machine learning you build, some internal data structure, think of that, internal data structure that it builds. Of course, most important thing is data set. If you do not give any data, so if you do not give any data, then there is no starting point. Once you give the data, machine learning tries to find the model, but in that process you have to either it has to learn or you have to tell it what features are important. If it is focusing on wrong features, you get attracted to somebody who looks handsome or beautiful, then it is fundamentally flawed relationship right there. If somebody is a wonderful person and plus beautiful, that is fine, that should be a secondary feature. The labeling, when in the training process for a trained eye, apple, orange, that labeling, training is basically model learns, and then prediction is when you use that machine learning in the field. So, during my all discussion I will separate always training time and prediction time. Why? Because training time, it is okay you spend 2 weeks, 3 months, gigabytes or terabytes of data you train it on. Like the way large language models are built, you need nuclear reactor to power them. It seems nobody minds. But when you are using that large language models to make the prediction, if at that time you need nuclear power, then it is a problem, because your car cannot use it, it does not have the power up amount of nuclear reactor. So, prediction time has to be low power, very quick. You show an image, it sees a pedestrian, it realizes it is a person, immediately it decides and puts the brake on. It has to be that quick. So, you are not going to waste time. So, that is basically prediction. Any of you have any question on these 5 terms, or some of the terms seems like they are same? Now, learning has different variations. I am going to talk about 2 major variations of machine learning, supervised and unsupervised. But before I go there, let me take a tiny test. So, let us say a kid is trained by showing a cat and dog. Your family has a cat, your family has a dog, or you have seen your baby on the street. Now, you take the baby to the zoo and you show a tiger. I want to see hands. How many of you think the kid will be able to say it is a tiger? How many of you think kid would be able to say it is a cat? How many of you say kid will be able to say dog? How many of you say kid will say, basically, which means I don't know, I don't care. Kid will always say it is a cat, because what kid is doing or the kid's mind is doing, because it is called AI or artificial intelligence, not for just for the fun. It is because this machine learning or this whole ecosystem is built around the idea that can we mimic the human brain. That is why the word AI. And the way these kids' brain work, it's learning some feature, knowingly, unknowingly. I'll come back to this kid's example later. It will call cat, why, what, we'll come back to that. So, the supervised learning idea is that when you train, you give level data. Remember the leveling, every image you put a tag saying it's apple, it's orange. I'm taking example of images, but it can be on text, it could be on anything, video and all, audio, all that stuff. So, you put a label. The difficulty, the good side of supervised learning is basically the model you build, that is very good. How do you know good? One of the metric is prediction accuracy. If you train enough, it may be able to predict with 90%, 99% accuracy, whether it is a cat or dog, right. But the predict supervised learning, as the name suggests, you are supervising it in learning process. How we are supervising? By tagging or labeling every data with what it is. If you teach your machine learning model only cat and dog, do not ask a question, does it have a tail? Do not ask that question, because it does not even understand what tail is. If you really want to do that, then you have to tag accordingly. This cat has tail, this cat dog, somebody has bitten the tail. You have to put that. You have to put that in, so that the model it builds it correctly. In supervised learning, do not ask a question, something you did not train it on. So, for example, here I am showing some stuff. So, you have bunch of male and female gender, age, salary and all that stuff, and then maybe once you train with this, then you want to basically certain characteristics, whether they purchase something or not. So, then once you show another item or an individual, would this person purchase or not, that is what the supervised learning is basically going to do, yes or no answer. And this is also commonly known as classification. So, supervised learning has two types of categories. When you need a yes no answer like cat or dog, binary answer, then it is basically classification. But when you need actually a value, then we call that as a regression. So, the basic underlying concepts are kind of similar, as you can imagine. This is much simpler model, this is a little more complicated model, and I promised I will not get into the probability or statistics, but there are a lot of ideas inbuilt in there. So, if you are thinking of this particular example, you are teaching it for a different temperature, pressure, relative humidity, different parts of the globe, the wind speed, it is teaching certain things about the model. Now, you are asking, today is Monday, the February 13, tell me what is the wind speed in Guwahati, then it gives you a number. I am just making it up, 2.4 kilometer per hour speed. Now, what is the actual speed? How far you are, that is the error. That is the accuracy loss or accuracy gain. Whereas here, if I ask 100 question, what percentage of the time is correct, that is the prediction accuracy. So, the notion of accuracy or error slightly different, but here it goes yes or no, like cat and dog, apple or orange. Here is actually you are going for a value. Here you make a mistake during training, you basically it classifies a cat as a dog, you try to figure out why is it. Was there in the original picture when I trained, some of the cat was looking like dog, there were breed and all that stuff, did I misguided, do I have to train little more? right. So, this is different type of breed, it never learned. Here it basically the error you get, the prediction of the wind speed versus actual speed, you feed that error back, and of course, there are equations, statistical regression, that is the idea. So, for this 2 weeks all we need to understand just the supervised learning, somebody is helping you. The other side is unsupervised learning. So, unsupervised basically nobody is supervising, right. So, supervised learning would be a parent telling the kid how to walk, where to go, not to go, do not go to the water, do not go near fire and all that stuff, do not put the water bottle near the table and all that stuff. But kids always intensity would be exactly whatever you ask, they will do exactly the same. So, this is basically actually good learning for parents. Those of your parents probably you do, if you do not do, I learned it from machine learning. I always ask my kid the opposite. It worked until he was 8 years old, reverse psychology. If I did not wanted him to keep it here, I always ask him, do not keep it in the middle, try to keep it on the boundary. He would always push it away from the boundary, that is exactly what I wanted. But after 8-year-old it did not work at all. He always still keeps saying, you keep saying you do not lie, you lied all your life. Now, you have to live with that, you have to live with that, right. So, unsupervised learning analogy would be, let us say think of an orphan who does not have parents or no elderly relatives, they are learning from mafia and people on the street and they are getting total crazy, they do not know what is right and wrong, that would be unsupervised learning. Even there people learn, people live, they also make amazing things. Anybody has any question on supervised learning, the data set is the input, every data you have to label and train for a long time, how long and all that stuff. So, in this context 2 terms are very important, one is false positive, another is false negative. Let us take the simplest situation, classification, to talk about it. You showed an apple and it said an apple, it is perfectly fine. But if you showed an apple and it said an orange, right, or something, let us say you showed an image of an MRI and it came up with saying it is not a cancer, but actually is a cancer, that is basically is a, in a medical term it become little twisted. When somebody says yes you have cancer, that positive is actually not a good positive. So, that is basically a false positive. It said yes. So, basically your tumor or cell is cancerous, picture or MRI and said yes, that is a false positive. And then if it says no, but actually the tumor, there is a tumor or cancerous cell, that is a false negative. Both, I mean both are dangerous, because if he says yes you have a cancer, people can have a heart attack and die, and if it says by mistake you do not have a cancer, you do not treat, go to the fourth final stage, people can still die. So, both are dangerous. So, therefore, having false positive or negative is not a great thing to happen. The prediction accuracy of 100% would be ideal, but that does not happen, you could quite realize. If you train too much, that would be also problem. If you train too little, that is also a problem. Again, let us go back to the child. In the child example, if you just say do this, do not do that and all, the child does not develop his or her own thinking ability. For the rest of the life, when you are not next to that person does not know what the hell to do. In contrary, if you never said anything to that person, you are just waiting, that kid got into these drinks and drugs and all that stuff, and you are like, oh, why did not I intervene on the moment, why did I waited for the kid to make right decision, mix with right people, that is also dangerous. Kid will go to the water, figure out, but that would be too late. So, let us take an example of a supervised learning. There are many examples. So, support vector machine is one of the earliest, from 1950s, 60s people are using it. It is not that popular these days, but what it does, it basically by looking at the data, trained data, it kind of plots. So, think of this data, some kind of size. So, 2 parameter it looked at, the size of the size of the tumor and where kind of that thing is, or in that scale, and you put kind of different places the cell is malignant, cancerous or non-cancerous cell based on that. And basically when you are training it, you labeled it. You told the system, by the way, this particular point is basically cancerous, this particular point non-cancerous. Now, how does that happen? So, in medical terms, doctor already has a database of the cells. They will hide the identity of the people, all the cell, whatever cell characteristics and which one was cancer cell. Think of an image. You are showing the machine learning tool images of cancerous cell, non-cancerous cells from different patients of different color, different gender, all across the globe, lot of data set. And everything you have marked, you are showing. And after showing all of that, think of you are a human being. This, ignore this red line for a moment. This data set is given to you. Next time, this is during training time. Next time somebody gives you a data right here, what would you say? It's malignant, because you know most of the stuff here. Ignore the line for a moment. Or somebody gives a data here, then you know that's kind of benign, near the benign ones. But somebody gives something else, kind of tricky. So, when you train, what the machine learning model, or I keep saying the model builds, actually builds a line like this. Here I am doing a 2D line. In general, it could be a complex n-dimensional plane. It may not be one contiguous plane, it could be multiple planes and multiple stuff. But still there is a notion of you are my friend or you are my enemy, you are with me or you are against me. There is no notion of neutrality in classification based machine learning. And in support vector means once you build the line, then now this is the training time, this is done. You spend 3 months, 6 months training this. Now during usage, we call it prediction time. I went to the doctor's office, there is a tumor, doctor took the whatever thing, biopsy, and then from the that report basically showed that to the system, machine learning tool scanned it, and it basically find the point based on these 2 parameters, find the point somewhere, and if the point is above this line, then it's basically cancerous cell. If this is below this line, then it's basically good cell. Anybody has a question with that? Now the problem comes with false positive and false negative. Now let us say there is a point, let us say point is right here, right here. Then based on this line, the model will say it's a cancer. But it turned out that person doesn't have cancer, for more tests or whatever second opinion, then you have to retrain the model. Then you have to retrain the model, maybe a new line will be drawn here. The line will be bent there, so new training and all that, if that's possible. And that's kind of a common feature. Whenever you have a car that runs on some level of automation, then it has a machine learning model that was trained. When you bought the car, it comes with well trained machine learning model. But new things it's learning depending on the roads you are driving, that original modeling time it didn't know. So that all of that learning, when you park or charge depending on the company, then it will send that data back to cloud, and that new trained data will come back from the cloud. So whether cloud will make the decision, that normally doesn't happen, because that takes a lot of time. Normal decision is based on the model that's on the car right there, but then there is a upgrade based on when you are charging in the night or all that stuff. Will the cloud, new modified model comes in based on the mistakes you did that day. So the notion of retraining is not new, but in this 10 days we will ignore retraining. But retraining is real life, but we will ignore retraining to avoid confusion. Any of you have any question on how supervised learning at the simplest level works? You trained it, it built a line or a plane, some separator, good versus bad, apples versus orange, cat versus dog, street cat versus good cat. Just by looking at it, can you figure out cat doesn't have, let us say, a locket or can you figure out is it a home cat or is it this? Assuming there is a machine learning model which can do that. Or it would be even better if somebody builds a model just to put on the face and figure out good person, bad person. That would be wonderful to make friends, right? So we talked about now unsupervised learning on the other side, the way I talked about orphan. where you basically you do not give it a label data, it just learned by itself, it learned by themselves. And how do they do it? Of course, I have to mention that unsupervised learning is more challenging. More challenging. How do they do it? By clustering or association. What is clustering? So, basically when you give a set of data, it tries to figure out that it belongs to certain cluster. For example, if lot of purchase data is given, people and what they purchase, based on the types they purchased, whether it is electronics versus clothes, or whether somebody is buying Samsung electronics versus Apple electronics, it forms a kind of group. Now you put in unknown people, let us say you put Professor Chandan Karfa, then it should be able to decide whether he is going to buy Samsung TV or Sony TV. It would be able to predict that. If you ask, is he going to buy a Samsung TV, it is going to say yes or no, because it looked at that and formed that clustering. Now, association basically by looking at the feature or data, it basically figures out if somebody buys milk, they are also going to buy bread. Now, this has been in use for a long time. Most shops put some of those stuff in USA near the door, because most people they figured out they are running in there and quickly they want to take something for breakfast, cereal, milk or bread. They have their individual dedicated sections, but these will be kept there. So, based on that they made association. If somebody buys this, they will buy that. So, even in the dedicated aisle they might even keep some of those stuff, but actual main aisle they may have more milk, different varieties of milk, but that association they make, and that is how. Or it also works when you went there to buy a phone, they will try to sell something else, because their data set analysis told them that people, if you can pursue somebody to buy something when they are doing something, they are likely to do it. If you have gone for visa interview in any of the US consulate, the auto people, if its normal cost is 100, they will ask for 500, and they will tell you, I will tell you exactly what they say. Normally 1 out of 500 people get their visa approved, and you are one of those. It is kind of gaining a lottery, this and that, and you will be so happy, you would be willing to give that 200, 300 to that auto guy. So, even the auto walas these days understand the idea of unsupervised learning and association simply by looking at your face and your happiness that you got the visa. Everybody does it, and that is exactly these models are trying to do. And there are many examples, K-means clustering, a priori algorithm, and so on and so forth. So, here is an example of a K-means clustering. You are plotting certain data, and as a human being, how would I cluster them? I am simply seeing which points are near and which points are far. The problem with unsupervised learning, what is the meaning of near and far? Is it a Euclidean distance? Is it a social networking distance? Is it feelings? What is it? Emotional Q, IQ, what is it? So, the metric is difficult, which I am not going to get into detail, that is a semester course, but think about it, the way you manually look at and figure out based on certain characteristics or features, either they are near or they are far. Think of Euclidean distance, if that makes you easier to visualize. Think of stars in the sky, the kind of stars or cluster or galaxy they are near, it is all relative. But if you zoom into that galaxy, there still might be hundreds of light year away from each other. But from your perspective or the scientific experiment you want to do, for them all you have to distinguish, are you near Milky Way galaxy or far away from Milky Way galaxy. That is all you need to know. Are you a social influencer? How many followers you have? That is a cluster. Or maybe you are also a social influencer, but I think if I am selling soaps, I want to pay money to you than that person, because that person is kind of more for clothes kind of stuff. So, that is kind of the unsupervised learning. The good news of unsupervised learning is the headache of training, where you have to level the data set, you do not have, and you will not know how much pain it is until you are starting doing some research. You have a tons of data, somebody has to painstakingly go through for millions of data and put a level, and anytime you try to automate and script, you know how it works, and then you try to figure out why prediction is so bad, It's basically it's fundamentally flawed. Which one is buggy? Any question on just the very basics of machine learning? You give some data, it builds a model. Think of builds a line or a separator, left or right. So typically separator left or right is on for supervised learning, and cluster basically it kind of tries to draw a circle. Either you are either within the circle or you are outside the circle. If you are within the circle, that's a cluster, and somehow it figured out that if you are within the circle, then it's a cat. If you are outside the circle, it's a dog. It still does the prediction. It still does the regression. So prediction and classification and regression is orthogonal to whether you do supervised or unsupervised. But of course, typically that's not the usage pattern. As I said, milk, butter, and all that usage pattern is different. Any questions or very basics of machine learning? Let me take a test. How many of you can explain me what is a feature in layman terms? I want to see hands. Yes, please.
The individual characteristics, let's say for a table it is the edge or maybe the color.
Thank you. Thank you. That will do. Anything if you understand in layman terms, then we are together. You will be able to follow everything I teach. Now I am going to zoom in a little bit deeper. The models that we are going to use for cybersecurity detection, lot of buzzword, but I will break it down to layman terms without using any equations except once. So now I want to talk about what we talked so far. You have a data set, then you do feature engineering or finding features, then you have the feature, then like support vector machine, you build a line, and as you can see in this line some different type is also in the left. So maybe it happened during retraining time or whatever it is, but build the time and then basically during prediction you kind of predict correctly, right. But for other approaches that you are going to do, you can have a raw input, you have a kind of neural network model, and then you have the output. So neural network all of you probably know, but it's still the basic idea. The way it's different from whatever we talked so far is basically, so basically each of the edges here will have a weight, some weight 1, then this might have weight 2, and so on and so forth. So basically then you are computing the summation. So for example, for this particular one, when you are computing it's basically computing Wi multiplied by xi. So what Wi is the weight and xi is that link there or not there. So for example, this one is connected to all three, but this does not have to be, or maybe there was another node it is not connected to. So that means xi for this one is 0, and so Wi xi when you compute, that basically means what is the contribution of this input on this node, and this story continues, and eventually somehow this information would be used to final prediction cat or dog. So that is the notion of neural network, layers of, and these ideas would be useful because people use neural networks today in some variation of it, and I will show a lot of variations, and most of the acceleration of these neural network basically tries to do how do I compute this multiplication as fast as possible, whether in FPGA or different technology. There is a whole day dedicated to different way of AI models and faster acceleration. But this is basically the idea. So as you can see, this feature engineering and all that, it actually does not build any of these complex structure. It only builds just a line. Somehow in some manner it builds a line, and you might say how that line is. Think about it. If this is kind of some x is a distance or size of the tumor, forget about this complex line. Think of a vertical line, x equal to 5. That is the line it builds. That means now you showed a picture of a image, all it will measure the size of the tumor. If it is less than 5 centimeter, yeah, it is good. If it is more than 5 centimeter, that is bad. So the actual machine learning model is nothing but x equal to 5. That is all it is. Machine learning model is equal to x equal to 5. That is it. But in deep learning or any of the neural networks, machine learning model is a complicated structure. There is lot of nodes, lot of edges, lot of weights. How these weights computed, forward, backward, I won't get into those details. Based on the data, these weights should be determined. How many layer do I need? 1 layer, 2 layer? Do I need a softmax layer at the end? There are a lot of research in this domain. Now, just to give you an idea, the way I talked about security conferences, there are lot of, if you are publishing, and Dr. Karfa talked about these ideas, that if you want to do research, publish only in top places. What are those top places? CVPR, AAAI, NEUR IPS, ICML, ICLR. So, there are these top conferences, and some of these conferences, let us say just take one example, ICML. Typical submission is in the order of 12,000 papers, 12,000 papers per year, and they typically accept about 3,000 to 4,000 per year. It may seem like 4,000 is a lot, but do you see, it does not accept 8,000 papers, 9,000 papers. So, that is why if anybody told you they are expert, they know everything about AI, they are lying. There is no way a human being can read 4,000 paper accepted in each of these conferences on an average, 5 to 6 conferences, that is like 20,000 papers, accepted papers. Then there are people when their paper do not get accepted, they put it on archive. There is no way a human being can read all these papers, it is not possible. You need whole life to read 20,000 papers, that happens in 1 year. Now, you do the math, you understand what I am talking about, but the rationale I am trying to get in here, that all these conferences and places, people are innovating new and new ideas of how do we do neural network, how many layers needed, what happens in general or for application domain. For automotive system learning method, these kind of structures are better. Just to overemphasize on my last statement, I will show you few example scenario. Any question on this one? All I want to convey that the basic idea support vector machine I talked about in the basic machine learning and what I am talking about now is drastically different. So, this is basically trying to build neuron like in our brain, unless you figured out already, synapses, the way synapses combine and synapses split, combine and all that stuff, that is basically how it is. Although we are far away from AI, irrespective of who told you what, actual human intelligence, because no matter how much computations we do, and if you are not sure what I am talking about, the robotic hand, high end robotic hand costs somewhere around $50,000 to $70,000. That is why if you look any of these early days cartoon things, just look at their finger, they are like this. If free YouTube videos, most of them, unless you are seeing some Disney or Pixar movies, all cartoon characters fingers, they are not moving, they are like doing this or head something like that, because doing these millions of finger movement and looking lifelike, it is a millions of computations, and no matter which person you talk to, how dumb they are, or you think they are the dumbest person you have met, ask them to pick up an object, and when you see how they pick up the object, effortlessly they pick up. For a robot with supercomputer installed in it, it will not look natural, it would be still like this and that, just to pick up a penny, and then you touch that thing, it will be like hot, as if it has done so much of computation. Touch your own brain, it is so cold. That means brain can do low power computing, all these neural network computation so effortlessly, so low power manner. That is what people are trying to do in a natural world when they try to accelerate, low power acceleration. They are trying to match the speed of human brain and low power of speed they are able to get, but low power it millions of light year away, millions of light. It is basically this is running in 25 hertz, and processors are running in gigahertz, that million times faster processors are running, still their robot finger movement looks so artificial. Anyway, until one of you can invent and come up with something, we are stuck with this neural network. As you can tell, I am not happy about it, but I am not smart about it either. Any question on this thought process of going for basic idea of machine learning to what is happening today? I am going to further build on this one for when I go forward. Yes, please.
What is WINX? I understand again, please.
WIXI, yeah, weight multiplied by the age, if there is a age.
Weight of what matter? Which weight?
So, weight is between two nodes, there is a line, and that line will have a weight. And with the simplest way to visualize, let me draw something here. Let's take a simple example of just two node, color, that is one of the feature, okay, and let us say weight, that is another feature. Of course, I should not have used weight, because now when you are making decision, let us say this is the decision node, no multiple layers, no complex neural, that is all is the decision. But the color I am attaching 0.7 and here I am attaching 0.3. So, that is how decision would be. When a new object is given, I am going to look at its color and with 70% weight, and I am looking at the weight with 30% weight, and then total whatever value it is, then if that value is more than 5.5 whatever, I call it cat, otherwise I call it dog. So, that is the feature. Which feature is, of course, that is not what happens in neural network, something else happens, but that is the basic idea. The weight comes from if this feature is enabled, then how much of that would propagate to the next layer or next node. Does that answer your question?
Yes.
The weight is basically something related to previous node in a general sense. In this example, it relates to that particular feature. How important with respect to other features. So, basically there are books on that, how many layers, and the easiest way to answer that would be you try with one layer, see the prediction, you try with two layers, then you see the prediction, try with different level, different number of features, then see the prediction, and you see whether your prediction is improving. And I will introduce the idea of gradient descent, then you kind of figure out, do I keep adding nodes, do I keep deleting nodes, do I keep all the edges. And this has lot more repercussion which I was not planning to talk. Just to answer your question, people actually try to see, can I get rid of some of the edges, yet I maintain the level of accuracy. And why? Because remember, all these weights has to be maintained in the memory, and all these multiplication has to happen. But if one of the weight is, let us say 4.1, another is 3.99, or one is 4.0, another 3.99, do I need to maintain those, or I can make both up 4.0? If some weight is really small with respect to other, can I get rid of them? That is known as compression. So, that is Songhan's work, and just by doing that basic idea, that was one of the first paper on compression, neural network compression. It is simply data compression. He basically said in layman terms, if there are a lot of values really smaller with respect to the other value, just make them 0, which is basically means get rid of those lines. And if there are multiple values with very close of them, make them some number in the middle, yet accuracy will remain comparable. Then you get significant savings, number of multiplication goes down, amount of memory recovered goes down, and he is a professor at MIT. The work is not that complex, but it is just that the impact of that work, everybody is using it, that is powerful. So, the number of layers, what is needed, and there are a lot of research on gradient descent, going forward, backward. Some of them are additive based algorithms, some of them deletion based. You start with layer and then you start deleting and see what happens. There are many such features. Any other questions? Yes, please.
So, in the traditional ML model too, the separator is also created on the same idea, like with some weight or some color based?
Here?
The
The separator is created based on what you observed, right. So, in this particular example, line was there, but in general line should have been like this. It probably tried and could not do it, because that thing is the blue one is a good type, So, you want to draw a line or plane such that all blue ones on one side, all red blue circles on one side and all red crosses on the other side.
Probably if you transform to other dimensions,
you might be able to. Thank you. Thank you.
What they are trying to do is actually trying to transform from regular domain to other high dimensional low dimensional, so that you can view it. If you are not able to see from this angle, try to look at from other angle.
From other angle or another dimension, you might be able to draw a separator.
Maybe neural network that trying to do that, nothing else. So creating dimension. Every layer is creating a new layer.
Yes, please. Every feature actually creates a dimension. That's a wonderful visual. I forgot all about it. Yes, please.
You are talking about the model being very complex and computationally very effective. So, what do you think is the most essential parameter which determines this, and what way we can work on it to reduce this complexity?
Right, that's exactly machine learning. Machine learning exactly tries to figure out automatically which feature is more important. Sorry, say again? In deep learning, it's trying to figure out that one.
Yeah, I'm asking like what is that we can work on to reduce this complexity?
Right, the complexity, as I said, the number of layers you can reduce. But if you do that, if your accuracy goes down drastically, you wanted to save your power or make it faster, but low prediction is not acceptable. So, basically then training is essentially putting the weights on them. Either delete. So, actually forget about deletion of the edges. Deletion of edges is making a weight of 0. So, it is trying to determine the weights of each of those edges. That is basically deep learning process. And during testing time or real world deployment, you basically provide the input and it would make the decision.
So, on the hardware part, so what do you think is the most essential part for this deployment?
Hardware part is the multiplication. So, you have so much of, for every node it's basically multiplication of all of that, and so it's basically multiplication followed by node. It's really all about multiplication. If you can do a lot of multiplication efficiently, and as you will see when you talk about tensor processing unit, if you can reuse some of the computation done by previous stage and all that stuff, that's the systolic array architecture in 1960s done by IBM. It came back and Google tensor processing unit made use of it, but we have a dedicated lecture for that. I will come back to that. Any questions on basic machine learning and how these two are different? Okay, now that we introduced machine learning, let us go to the little bit of insight into the model training. So, then there are two important aspects, training and testing or prediction, training time and actually real world uses. And I want to repeat again, so that training time you spend 5 days, 5 months, nobody cares. But testing time, as long as it is low power, fast, accurate, that is all people care. Same thing about when Dr. Karfa is going to talk about compilation in embedded systems domain where I come from. Even if your compiler takes 5 days, nobody cares. But if that compiled code takes low power, runs extremely fast, meets real time guarantees, that is what people care. So, for malware detection, for example, how would training happen? You have a data set in, so this is a data set of which register has what value in what clock cycle, that is your data set, and then you will have some kind of, either you choose or you kind of, somebody told you what would be useful, you use some kind of recurrent neural network, some form of neural network, and then the training strategy is basically gradient descent. This is people normally use. So, basically the key idea is you start somewhere, think of the weights you assigned or whatever you do, and then you keep changing weights of different edges, keep removing some nodes, keep adding layer, and every time you are seeing, am I going to the, so here gradient descent idea is the lowest point is the point where it would make better prediction. That is the whole idea. And the analogy would be, you are on top of a mountain and the objective is you are blindfolded, you have to go down to the valley. You saw once whatever you wanted to see and then you got blindfolded, and of course, it is not a smooth terrain, you are going to hit bunch of trees and ponds and whatever stuff, you have to go to the valley. So, when you hit something, you take left, you take right, those are the gradient descent. So, your leg is telling you this surface is going down, this surface is going up. Now, that is a local optima, because even if some surface looks like up, maybe 5 minutes later it will go down faster than the surface that looks like it's going down, but it might be down and then wandering around and never going to the valley. And this classical problem, you don't have a full view. That's why I said blindfolded. Even if I don't blindfold you, think about bunch of trees and forest, and you don't see all the way to the valley. All you see two street. In general, it's more complicated than that. Two street, one goes like this, one goes like that, and your intuition will say some street which has a lower slope has higher likelihood in going to the valley faster than something like looks like this. But globally, you don't know what will happen 5 minutes later. You have no idea. So that's basically gradient descent algorithm. It's trying to do optimization, but the key idea is every move it does, removing a node, removing an edge, changing a weight, am I getting lower value in terms of this value? Am I going down better accuracy, or am I doing worse? So that's basically the optimization you do, and then there are many other mathematical formulations so that you kind of say you don't make lot of bad mistakes and end result you assume I will be a billionaire. That's not going to happen. Any questions? So these are the kind of key ideas in high level layman terms. In details are different. Now I am going to get to one of my favorite, zero shot learning. Let me explain you the context. You trained with the horses.
In your previous,
yes, please.
Title was malware detection.
So we have a whole day for malware. So we will get to that, but this one is malware detection, because in malware all the publications they basically use recurrent neural network, they use gradient descent, and they use this kind of time data structure. So some data across clock cycle. So this has been known and understood, but if this was not understood, if this was not malware detection, I cannot put these three names next to each other. It could be anything. It may not be gradient descent, that might not work. It may not be recurrent neural network, it could be some other neural network, and it may not be the trace buffer data or the data I am showing. Maybe this data type, this data has to be reformatted differently. So these three major steps I just showed. Training strategy for all machine learning, you need a training strategy. What strategy worked for malware, or at least the ones people published? This one worked, but it is not guaranteed to work for other scenarios. We will show a lot of other scenarios like image generation, like large language model. I will show in a minute if time permits, right. Does that answer your question? Okay, so now zero shot learning is my favorite. The idea is that you can train with the horses and then you can test with the zebras. Or that I think that example is still silly. You train with horses, ask with apples and oranges. Ask that model to classify between apple and orange, which I have never seen in the life. So there is in between I didn't talk about. So supervised, unsupervised, you train a lot, then you ask on the same type of data set. That's assumption. Zero shot learning is basically on a different type of data set, and it still should be able to make right prediction. And in between there is something called one shot learning, and the key idea is you train with a data set, you can spend 3 months, it is all right, but now before testing on a new domain I will give you 5 minutes, 10 minutes, you want an hour a day, it is all right, that is it. You are not going to get 3 months for training. How do you do? So there are a lot of examples, and even in a lot of Indian projects, lot of US government projects. So for example, there was this project on autonomous vehicle project. The first project DARPA started is that how far can you drive, or your autonomous car, you can't have the remote. How far can it drive on a desert in between Las Vegas and Nevada, one of those deserts. So you can train your car or whatever model you have, whatever things you want to tell it, how many cameras you want to build, how fast you do camera processing, it's all fine. But when you go to that terrain, terrain was not disclosed earlier. When terrain was shown to you that it is a desert and you can see whatever you can see, how far, if you want to tell it certain things, that's all right. But you have 15 minutes, half an hour, 1 hour, then whenever the DARPA program director says go, you have to let your car go. And whichever car goes the farthest wins that $1 million. Those days $1 million was a lot of money for researchers. So you can win that $1 million prize. And these days I am part of that project called Tiamat. This also has a $1 million prize that goes to pocket actually, not to the research. That prize is your model would be trained in a different territory and it would be tested in a different territory, and that example is so think of a robot or an agent moving into a simulation environment where this particular analogy is simulation environment where you have doors are like square and my apology, windows are like square, doors are like rectangle, and so on and so forth, and then there is this agent, think of a robot in an online environment, is going to walk to pick a spoon. Now, you need to figure out, first of all, it's after hitting walls and all that, very 2D kind of environment, you need to figure out that how spoon looks like, you need to know, you have to train and label that an object of this kind is spoon, an object of this kind is a fork, and all that stuff. You need to also understand spoon is likely going to be on dining table, so you need to understand dining table, all that stuff. It has to, and fastest possible way, it need to go there, pick it up, and maybe or maybe it need to find it in the fridge, pick it up, close the fridge, all that it has to do. It may not be a direct action, cat or dog. Now, the work or the funding is, you can take 3 months, whatever lifetime for this, then the testing environment they will give a real simulation 3D. Think of this is a 2D simulation environment, this is a 3D simulation environment. This could be inside the room simulator, this could be outside the room simulator. So, simulator to simulator, and then once we become successful, this is phase 1 we are in, then phase 2 would be this, then they will give the phase 3 simulator to, this is real world. Now, they will give a robot, you have to take their robot, you can take the agent or machine learning model, they will give you 1 hour, you take that model, put it on the real robot, then you have to place it. And then there will be objects that your simulator, your agent never seen. For example, it understands shoe, but it does not understand slippers. So, you have to quickly, I have to quickly type slipper equal to shoe. So, that means when I am training this, there might have to be some kind of textual prompt engineering where I can say slipper equal to shoe and stuff like that, and it should learn and digest. So, it might have never understood what is spatula, what is a cooking spoon versus teaspoon, all that stuff. It quickly 1 hour, whatever you can do, that is one shot learning. You have one shot and that shot is really small and you can train. At 0 shot learning is basically none. You train some environment, you will be put in a different environment and you should be able to perform. This is probably logical place. So, this is 3 o'clock, let us take a break, we will meet at 3:30.
Just one thing I want to ask you, the lunch break is from 12:30 to 2, right? So, you want us to start from 2:30, will it be convenient for you? Or 2 is fine? So, we have to go all along to the hostel, have lunch and come back. So, we are okay with both, but today I just, when we are coming back, we are discussing maybe 30 minutes maybe too short for the candidates to go to hostel and come back. So, should we start from 2:30 from tomorrow? Second half will start from 2:30. Everything will be shifted by 30 minutes. Okay. So, we will come back at
Good afternoon. We are going to now continue talking about explainable AI, and in the last lecture we talked about zero shot learning. I wanted to show a use of zero shot learning for Trojan detection. Also, although Trojan is dedicated for one specific day, but I just want to show a funny interesting spin about it, zero shot learning. Just to recap, zero shot learning is where you are given enough time to do the training, but the data set or the type of data you trained on, the questions that would be asked or in the field, the data set is totally different. And zero shot learning says you won't be given any time to do any adjustment to your model. You should be able to just keep working. Yes, please.
In traditional machine learning or deep learning, so if I am training like on horse data for zero shot learning, the feature set will be different, the underlying model and weights will be different. So when I am trying to predict, like you said in an example, an apple or an orange, then the entire feature set would change. So is it the model that selects the feature set for the new one, and like the new set, like testing one that we are giving apple and orange, and if it does change, like how like the model does, like underlying model does it change completely?
So, you asked two questions. So, both answers you have to wait. So, the first one you have to wait only 2 minutes until I finish this slide, which is how does it work. It was trained on different set of data set, different features. So, how did it is not even supposed to work, how does it work? For that, for but your second part of the question you have to wait for a few days, but this one basically you will see the first part of the question you will see right now. So, let me just recap. We already talked about supervised learning, where you have a labeled data set and then you have a separator. In this particular example, I am not saying what data set it is, it really does not matter. The basically the pink slash whatever this brown data set is one type of data and blue data set is one type of data, and for the testing, after training the testing, that is the green oval or green circle. So, because the green circle is above the separator, so then it would be treated as like of blue type, whatever that is, cat or dog. So, that is basically supervised learning, but the assumption is you need a golden reference basically, because you are talking about Trojan. So, this is basically Trojan inserted, this is Trojan free, this is good, this is bad, actually it is opposite, but either way. So, that a reference is needed. But in the community, if you talk or work, people will say I have a design, I do not have a golden version of it, I have just one design, tell me do I have Trojan or I do not have Trojan, is it good or is it bad, I do not have a reference model. But for a normal human being it is hard to kind of understand that. If I want to hire a PhD student and I say good, I think you have a good potential, I want to hire you, how do I say it, what is the notion of good? Is it I am looking at your GPA, and because your GPA is 3.9 from IIT Guwahati, that is why good. So, although I am thinking that way, but I have a golden reference that IIT Guwahati is a top school and getting 3.9 in IIT Guwahati is very hard. So, this student must be, first of all, got into IIT, therefore, has to be brilliant, got a 3.9, that means very hard working. So, I do have a golden reference. What would be analogy of no golden reference? Just a student showed up, does not want to say which university they are from, what GPA they have, none, you have to decide. Then that would be golden free Trojan detection. So, for doing that, something like unsupervised learning would be ideal. Unsupervised learning model was trained with some data set, some benchmarks, but it was there is no labeled data. Now, you gave a basically a new benchmark or new design and you asked is it Trojan inserted, Trojan free. Basically, the system is trying to see is it inside the circle or my cluster. Remember I talked about clustering as one of the mechanism, it is trying to see is it inside the cluster. Now, in reality the way the golden free Trojan works, or we try to do, we try to combine the advantages of these two. And how did we do that? We did a supervised learning based training, then we kind of do Trojan detection using unsupervised learning. Now, you might be saying wait a minute, that cheating, The moment you do supervised learning, that means you have a golden reference model. Then this whole idea of golden free, that is hypocrisy. Can anybody tell me why that is not a hypocrisy? You can lie, yet you could be an honest person. How is that possible? You could be lying all your life, yet you are an honest person. Sure, go ahead. No, I mean, oh yeah, that would work, but let us say there is no fallacious argument. Yes.
I have a general.
No, you can sit and ask. Yes, please.
I can provide you a general instance which is beyond machine learning and AI.
Yes.
See, let's consider a scenario. See, suppose there is a dog and the dog is hunting for a cat, okay, and the whole incident is happening inside a forest, and I am presenting inside a forest, okay, and okay, forget about the dog, just consider a hunter. A hunter is hunting a cat, okay, and I am presented inside the forest, and at a certain point the hunter asked me, do you see the cat? And I replied, no, I have not seen the cat. Or instead I just replied, I told him about a wrong direction, that the cat went away to that direction, but actually the cat didn't go to that direction. So at this point I might be lying to that person, but I think at this point lying is justified just because telling the truth put much evil
To the cat. Thank you. That is the correct answer. Now, in this particular case, we are using the same analogy. So, the analogy, the designs we are training on is some academic designs. Let us say I have in my lab, I inserted some Trojans and I am training on those. Why people wanted golden free? Because the company has only one design, that multi-million get design, only one design they have, they want to know. So, they do not have golden model. So, that is the truth, and this is fine. In my lab I have like my students developed in my class lot of designs, inserted lot of Trojans, that is easily available. Just because I said I would not lie, that does not mean I have to put that example in the cat in the danger of life. I do not have to do that, both can be achieved. When lying saves somebody's life. Now, this I train with, but when I do the testing time, that particular time is unsupervised learning, because it has not seen. Now, the question basically it works, one of you actually gave this idea in the morning, I thought about it and modified a little bit. So, the reason it works, for each of you to understand how it works, that magic, let me ask you a question. How many of you have gone in the web and seen this 3D barber? 3D barber, how many of you seen one? So, I want all of you to kind of go when you have time, but do not do any other social networking stuff, then do not blame me, because once you see that it will show you some suggestions, please do not do that. But in 3D barber, when you put your headset and close your eye, you will not be able to believe that actually haircut is not happening. Haircut is happening on you, and literally your first reaction would be, oh my God, hairs are falling here and there. Yeah, that would be your first reaction, it is that real. So, the math behind that is basically the sound, the way sound gets created in your ear, or whatever way this malleus, incus, stapes, all those bones, if you recall, the way those bones get affected is basically gives you that depth perception. Regular headset, regular stuff, you do not need any exotic Bose speaker, okay? Regular stuff, cheapest headset, you will get that feeling. The scissor is running here, there, and somebody is talking, moving around, and you will be like mesmerized, right? Then similarly, so that model, similarly there is another model where from a blank model you would be able to train on handwritten digits like 1, 2, 3, 4, those digits you can train your model. Now, you ask that model show some apples and oranges, and it would be able to predict. So, these examples, let us take the simplest one. Somebody trained on handwritten digit, and you are asking it to distinguish between apple and oranges, which it had never seen, It does not even know color. If you give two colors, one red apple, one green apple, it will be able to 100% accuracy. I have tried hundreds and thousands of times, it has 100% accuracy, trained with the handwritten digits. My question is, why do you think it works? Handwritten digits somebody trained with, and it is able to distinguish between red apple or green apple or between red and orange, it would be able to classify, put them in different buckets, which it had never seen in life. How does it work? One dictionary word, it is in this slide, similarity. It learns similarity, something is similar, something is not similar. I forgot to say that when I was talking about unsupervised learning, that is the catch. Something is, remember I keep talking about cluster, something is within the cluster, something is close to me, something is far from me. I was trying to talk about Euclidean distance, real word is actually I was looking for similarity. It learned the similarity between handwritten digits by different types of digit, different way of writing 1, different ways of writing 2. It is trying to figure out that the 3 and 8, no matter how you write, they are different. It should be able to, so this is somebody wrote 3 like this, somebody wrote 8 like that, and it should be able to kind of figure out that no matter how you write 3 and 8 or this way of 8, whichever way you write, it should be able to figure out these are 8, these and these are 3, similar and dissimilar. That is what it learned, similarity. Cat, and the kid was able to figure mistakenly think a tiger as a cat. One is similarity, second is whisker. That was the feature in the brain, although kid does not know what is feature engineering, that is the feature match. That was the most prominent feature for the kid when it looks at that one. Maybe big and small kid did not figure out, because if kid figured that out by then, kid would have said dog, because typically dogs are bigger, cats are smaller. So, this one is even bigger, so then it would have figured out it is a dog, but somehow size in kid's brain did not register as a important feature, it is not important. That is why kid never tells you when they want to go to number 1 or number 2, they do not tell, because they do not think it is important for you to know, they will just do it on the pant, right. It is that is how their brain is programmed, what is important, what is not important. And then there is reinforcement learning. Kid will keep crying if they get a cookie or biscuit, if you keep giving to pull them down, they will just, that is basically the cycle, that is basically the cycle. So, is it clear how does it do? So, it is still golden free, the way it is theoretically said golden free, although that would be my lying, but it was trained with a small set of designs, but it works on large real world designs. And because simply it learned, the model learned what is similar, what is not similar, what is Trojan, what is non Trojan design. Any questions? Yes. Sorry, say again. Yeah, number of classes is same, Trojan and non Trojan. No, this particular case that is not the scenario, but it would still work. In your analogy it would still work, but that is not the scenario. These are also Verilog designs, tiny, developed in lab. These are the designs from the company, millions or billion lines of gate.
So, for the testing part, if I have three different fruit, it would still work.
3 different designs?
3 different fruit categories.
It should work if it was trained that way. If it was trained that way, that you, I think I understand your question. Your question is, we did binary classification, if this is a ternary classification, so you change 2 parameters, I need to check, I believe it would still work, but only parameter I was changing here, size of the design. One is industrial scale, another is tiny silly toy example. So, now I want to introduce reinforcement learning. Instead of telling them the concept, I want to apply on again Trojan detection, just to show you how is it different from zero shot learning, support vector machine, k-means clustering, all that I talked about. The idea of reinforcement learning is basically that you have a design You are trying to figure out if it has a Trojan, you extract certain values, parameter, you evaluate, and then if things are fine, then you basically reward it. In this particular analogy, details are not important, you are flipping one of the bit. Which bit to flip, which bit to not flip. If you flipped a bit, you got some benefit, you keep that bit that way. If you did not get a benefit, you flip it back. So, that is kind of the key idea. Reinforcement learning is something that works, you reinforce on it. Like a kid, if kid cries and you give a cookie, that is a reinforcement, that is not what parents should be doing. But when the trainer trains animals, they want to make sure go and fetch this ball, if it fetches the ball it gives a cookie, dog learns. Or the Ivan Pavlov's that experiment, you just ring a bell and then basically its saliva starts going out, it becomes hungry, although maybe scientifically, biologically it is not actually hungry, but it is just the very act of that bell creates that instinct for the dog to eat. That is the Pavlov experiment, right. It is all reinforcement learning. If you are walking in the right direction. So, how it relates to machine learning? Remember, machine learning is all about building a model, it is trying to search or make a decision. So, if it is searching or building a model in the right direction, you are rewarding it. If it is building a model in a wrong direction or building bunch of branches that are wrong, you are saying do not build those branches, do not build those subtree, those decision trees, do not build it, then it does not build those trees. So, that is the idea of, so then there has to be an idea of somehow evaluating the parameter, and then idea of if you are right direction, how do I reward, whom do I penalize, that is the reinforcement learning story. So, reinforcement learning is widely used in the machine learning community, knowingly or unknowingly. And if you want to get into AI, first thing you have to do, assuming you are using Python, Python comes with this library, beautiful library for any of these work. Early days it used to be hard, you have to write, you have to learn CUDA programming, because most of the machine learning algorithms, the iterations, training, it takes so much time, you can't do in your laptop, desktop or general purpose processor, you need a NVIDIA GPU, whether GTX 2800 or A100, whatever it is, you need one, and for that CUDA programming is needed. But these days things are easy, because NVIDIA being close to $1 trillion company, they build the ecosystem and all the Python library exists. As long as you use those Python, PyTorch, those functions you call from a library, run, it would generate without you knowing the CUDA, whatever commands, CUDA programming. The day I talk about GPU, I will show examples, CUDA programs, and you will run it on GPU if you are running it on GPU, or if you do not have a GPU backend CPU, it would run on that. Now, I want to apply this, slowly I am going towards large language model, but the way I am building the steps slightly different. Now, I want to apply all these cats and dogs enough. We are doing classification, telling the wind speed. Now, I want to generate some images, right? All these deep fake and all that stuff large language models are doing. I want to talk about some of the core technology in there. One of the core technology is image generation. It generates lot of images, lot of data. If you ask it to write some story for you, the love letter you should give it to your whatever better half or worse half, it will create that for you. Whether it would hallucinate, that is a different story. How does it generate? What does it do with? And even when it generates, what happens? So, while you are talking about this, so two things I want to talk in this, I will make it a little more spicy. I am going to tell you that let us assume your training data set for the large language model itself is biased. If things are biased to start with, so then decision is going to be wrong. In fact, large language model have a different problem. It creates images or stories and that goes to online, then it uses that to train itself. So, you are basically, that is what called hallucinating. You are generating some fake story and then you start believing, and then you generate more fake images, fake stories, and then you feed it yourself to train. So, basically you are just biasing yourself in a wrong direction. Right. So, when you are believing on social networking, that is pretty much what you are doing. Now, what I am going to show a simple example and then slowly introduce some more ideas even before you know it. So, here is an example of a data set, Can anybody tell me by looking at this data set, is there any bias in this data set? What we are trying to solve here? We have a data set, we want to build a machine learning model. Before I build the model, I want to ask myself, is it unbiased? Because if thing is not unbiased, if you build a model with this, the decisions it is going to make, then it is going to be a problematic decision. Because let us say I give you a data set with 99 cats and 1 dog, that is what it was trained with. What do you think it is going to predict all the time? Cat. Everything, anything it sees, it is going to call it a cat. Whether it is a mouse, whether it is an elephant or dog, it does not matter, it is going to call it a cat, because that is what you trained. What is the bias in this data set? Okay. So, for good observation, this is actually not small, this comes from this data set Smithsonian butterfly, and they just put a scale on it just to show how big this is I can't even see 2 centimeter, what is it, whatever it is, that is basically the scale. So, this is actually not small, that would have been definitely a bias, one of them is small. Let us assume that is exactly same size. Any bias, anybody say anything else? Size would have been a bias definitely. Yes, please.
All the butterflies have patterns. So if there is a butterfly which does not have any pattern and it is blank, then that would be a bias.
Do you see a bias here?
All of them have patterns,
So
but
but there is no bias. That means that is good. Oh, you are saying in nature there are butterflies
Exactly,
which
sir.
has
yes.
no pattern.
So it should include examples of butterflies that don't have patterns.
Okay, that is the correct answer. Let us assume
Color.
all butterflies in this world has patterns. Then do you have a bias?
Color.
More yellow. So color is a pattern. So all I am saying is finding the bias itself is a hard problem. That has hundreds and hundreds of paper. How do we determine bias? What about the bias that we do not even know of? Certain biases we know because of psychology, philosophy, all these studies, certain bias we know. Here let us say color is one of the bias. Let us try to compute it. Yellow butterfly 6, blue butterflies 2, I do not know which one I counted as blue, this one and this one, and class imbalance is one of the metric. There are so many metric of bias. Class imbalance, so there is 0.5 class imbalance. Ideally class imbalance should be 0, right? That should be 0, right. So, how do we get rid of bias? Now that we know there is a bias, class imbalance, let us say there is class imbalance is a problem. How do I reduce the bias in the original training data set?
More instances, samples.
Of
The lesser represented data.
lemon terms, what exactly do we need here?
More of blue.
How many more?
3, 4.
4 more butterfly. Anybody thinks that is a bad idea? Nobody thinks that is a very bad idea. What if in the nature the ratio of blue and yellow butterfly is exactly this? Then the decision machine learning makes is going to be wrong again. That is why one of you was trying to go, I do not know which of you, trying to explain in one of the question that it is the perspective. Bias, that is why determining bias is a hard problem. Everybody when they kind of do any movement, everybody is biased by their own personal need. That may not be good for society. This is not a sociology class, but I want you to carefully understand when you build machine learning model, you want it to make predictions that is accurate with respect to the universe today. We do not know what will happen to the universe 100 years later, that is accurate to the universe today. If cat looks certain way now, it should predict that animal as cat. How cat will look after nuclear war, everything becomes green, that is not the machine learning model's job, because a human cannot do that today, and the AI job is to mimic human intelligence more efficiently, that is the objective. So, that is why bias is a problem, but assuming it is uniformly represented, then it is fair to add. Is there any other way? If I hate add operation, remove 4 butterflies, 4 yellow butterflies, yes, thank you. So, let us just say we generate, okay, we decided to generate. So, then if we decided to generate, we will generate 4 blue butterflies, and then that would be a problem. Anybody see a problem with this slide? We generated 4, the system generated 4 images, and how it generated I will come to that in a moment. I will introduce 2 more machine learning model. Anybody see any problem with these 4? So what happened to the second one? Yeah, it does not even look like a butterfly, right, because we got used to. No, none of you are complaining about my stomach is supposed to be below my chest, I have a big belly. So, if you are not complaining about me, why are you complaining about that butterfly? Nonetheless, for us it is okay to eat a lot, and it is not okay for a butterfly to eat a lot or have a disease, but this generation was faulty, I accept that, right. So, if you make some chicken in a restaurant and if it get burned, you call it a burned chicken, right, charcoal burned chicken or something, sell it for higher premium, some idiots will pay for it. Okay, then class imbalance becomes 0. Now, let us talk about this generation itself. Now, I want to zoom in, do not lose the context, I am trying to get to somewhere large language model does. So, now I am to zoom in, how do we generate these images? I want to generate them, right. Before I generate, I want to throw you some ideas of interesting ideas. Hallucination I talked about, large language model generates the stuff and then feeds itself, because it is always trying to search the web and learn and all that stuff, right. So, I want to show you a beautiful intricacy between data bias and privacy. So, before I go there, I want to talk about an idea called membership inference attack. When you have a model, there are research to show in that model, let us say the model of professors in India and or how much salary they make. In that data set, is Dr. Karfa there or not there, I will be able to determine through member inference attack. Now, if Dr. Chandan Karfa was in Europe, privacy is an important thing. He has legal right to tell whoever maintains that machine learning model, although it does not have his name. He has a right to tell them, remove my information from that model. There are 2 ways of implementing. If you want to build a model, then so here is the model, and then this model Dr. Karfa does not want it to be named. So, one option is this model came with the data, right, from some data, that data has Dr. Chandan Karfa's information. Now, we could do D minus Dr. Karfa, we can do that, and then we can build a model M prime. It will take another 3 months, whatever time it take to build the model, lot of energy and all that. Or is it possible from this model we just do minus Dr. Karfa, and can I get this M prime? Answer is that is possible. In today's technology, you can take a model and you can say which data you want to delete, it will delete. Remember that model, think of the neural network, it has bunch of nodes and bunch of weights, it does not have even name or character or even gender, nothing is there, but still membership attack will be able to do. So, this subtraction will achieve this task. This is good for privacy, right. But the thing is, everybody else will say, you will say, I will say, I want my name to be removed, everybody will say our name should be removed. Ideally, it is not a problem. We can remove all the original data set and add lot of synthetic data set that generated images, generated information to create the final model, and that is the classical the paradox of large language model, that if final data set is fully based on synthetic, the predictions it make, its accuracy goes down. And the reason it goes down, I am not going to zoom into there. The original data set, if you plot with certain metric based on certain Mohanlanabish distance, based on that Mohanlanabish is the founder of Indian Statistical Institute. Mohanlanabish distance, if you plot it, or if you look at the distribution, let us say original data set plots that way based on those, but the synthetic data set, if you plot them, let us see if I can pick a color, different color, that is red, let us pick green. If you plot those, it is going to have nice distribution, but it is not matching with the distribution of the original pattern. It has a slight variation, and that is basically causing this the accuracy loss, and this is basically a problem, same problem in a large language model. that is basically producing crap and learning from that crap and producing more crap, which does not represent the reality. And that is why if it asks whether draw me a person that is writing in a left hand, because most of the pictures in the web is not left hand, it is going to give you a picture of somebody writing in right hand, and that the model believes it is giving, and with the high accuracy, I do not remember exact 99.98% accuracy, it is going to say this is a picture of a person writing in left hand, although it is giving this, because that is how it was trained. That is the data. 99.99% of the data in the web are people writing in right hand. It may not represent the number of people who are right hander than left hander, but that happens to be the pictures how it is on the web. Any questions on this story? So, this privacy, this hallucination and this data generation and that all these problems, fairness, all of them has intricate roles in the society. Yes, please.
So, let us take the example of the butterfly. We generated 4 blue color butterflies even though the possibility is less, and can we also substitute that in the initial data set?
We will that is the whole objective. We will put those 4 in the original data set. Now, we build the trained model, that was the original data set, but the point I am trying to make, this addition of 4 blue butterfly will not represent the original data set's behavior. We assumed it is biased, that is one story. Even if it was not biased or whatever it was, this generated images have this side effect of hallucination side effects. The distribution does not match the original. Now, remember, original distribution I assume as correct. It could be really random or weird, whatever it is, that is what it is. Maybe Professor Karfa is the only one publishes in top places, that is what it is, whatever it is. But the generated data is not going to reflect the pattern of the distribution. That is why the problem is, that is why large language model, or at least if you are using any of the old one, new and expensive ones I am hearing these days. As I said, I can't tell you I know everything, I am hearing they are doing reasonably accurate. So, in any of the old one you are using, they are going to be totally bogus job, and then even if you do prompt engineering, keep telling. So, pretty much you are asking it to write a program, you have to write the whole program yourself by telling, okay, you should not, I asked for a if statement, it should have only 2 cases, not like 5 cases. So, you are basically keep on guiding and guiding and guiding until the last comma and full stop, you would have written the program by yourself. It is not no use, it is not learning anything anyway. How does all these images get generated? I am now zooming in. Okay. So, one of the key ideas is generative adversarial network, that is a big name, the generative word means it generates. Adversarial, there is fighting going on, adversary and network. So, what is this thing? It has 2 broad components, discriminator and I should have written generator on this side, but either way. So, generator and discriminator. So, generator as the name suggests it generates. I did not get into the lot of issues of maybe I have example, but the generator will generate an image and discriminator will try to discriminate, can I tell is it synthetic or is it original image. As I go along I will show some nice pictures. So, I will ask you, is it, do you think this is an original or a human being who exists in this world or somebody does not exist, and you will see how difficult discriminator job is. So, initially generator will generate images and discriminator very quickly will be able to tell it is not, it is fake. But after a point generator kind of figures, oh okay, let me try, let me do little more. After certain point discriminator will not be able to discriminate between original and generated image. So, that is when this one finally produces the data, that is the idea of generating adversarial network. It has many variation and there are hundreds of variation. I am operating on images because it is pleasant and friendly. It also operates text to image, image to text and all kind of thing. So, basically cycle gun, if you have a picture of 2 zebra, now you want it to produce image on horses, it would do a fantastic job, zebra to horse, horse to zebra. So, it basically learned images of certain type and then you will ask you to generate, it can, cycle gun can do. And remember, these are some of the papers from those top conferences. I am showing one image from each of those papers, 4000 I just chose whichever I liked. Then there is style GAN. You want to fall in love with any of them, kid, girl, guy, none of them are real, all are fake. So these people don't, I can guarantee you these people don't exist in the world. These are generated by our own research. So none of them exist, but they would look so real, and you can prepare the way you want, the moustache, the hair, the look, the eye color, and or glasses, whatever, how big belly they have, everything would match, everything up to the minute details. Style GAN is so perfect these days. And in fact, when you give a picture and you want a video, it will create that too for you, so accurate. And by the way, all these are basic inherent ideas in large language models. Large language models do so many stuff. I am just trying to touch upon one or two ideas there. So you can generate videos, time lapse. So, but the GAN has lot of challenges. One is basically it's fast, good part. Let us talk about positive. It's very quickly, in few seconds it generates images out, but the quality is not good. Not good to what? It's all relative, right? When I grew up, we used to have those the VCDs where I couldn't even differentiate which one is Shahrukh Khan, which one is Madhuri Dixit. It's like male and female, you can't distinguish, and we are still comfortable, happy. These days all these, I don't know, Blu-ray and high definition, depth, people still complaining, this movie, this, so expectation is different, right? But here compared to that, compared to somebody which I will introduce next slide, this quality is not good, right. So for me this is wonderful. So basically it's very fast, but the quality is not good. So if you want to make quality good, this is the idea is diffusion model, and most large language model now based on diffusion model. I will tell you without getting into equation, I want to just explain the idea. So you start with a nice image, original data set image, you want to generate images representing original data set, like the butterfly, you showed some think of this as a butterfly and then blue butterfly, and it is going to generate more. The way diffusion model work, it will keep adding noise until it becomes totally noisy, and then you start with completely noise, start removing noise until it generates the picture. It learns this process forward and backward. What is the catch? Catch is, if I am able to do this, if it learns this story, I can ask it to stop anywhere. I can start with nothing and then ask it to stop here and say, give me an image. It will give you very good quality image. Longer you wait, it is going to be higher quality. By the way, this is showing it is not going to generate this image. I am just showing you the process. If you ask it to stop here after third step or fourth step, even if you ask it to stop completely random noise, it would still produce a beautiful picture, because it learned the story of adding noise and removing noise. That is the idea of diffusion. So if you have a water, you drop some sugar, you do not stir it, and if you sample some water near where sugar is, it is very sweet. Further you go, it is less and less sweet. That is the notion of diffusion. I did not realize until I was in 5th grade. I went to the neighboring state of West Bengal, that is Orissa, and I realized, so the people do not start speaking Oriya the moment Bengal boundary ends. It is like kind of mixing of, and the same thing on this boundary. People are not completely saying Bengali in the villages on the inside West Bengal. There is a mixing of Oriya and Bengali. So then it is the same diffusion idea, that even language, dialect, I mean the people who are trying to speak pure English or pure Bengali, that is different, like Calcutta kind of English. But most of the villages, the local dialect is a very, very fine mixing. You go kind of 10 or 20 kilometer, then you get fine Oriya that side, or 10, 20, 30 kilometer, then you get fine Bengali on this side. This is the same idea. You keep on adding noises. In this case, you keep on, depending on whose perspective, his or mine, you keep on removing Bengali or you keep on adding Oriya, then you get that local dialect of that village. And that is the key idea of diffusion based image generation. The same idea works for text generation, video generation, and everything. Any questions? There is a lot of math behind it, but that is the key idea. Now if I want to do diffusion here, diffusion model here, I want to show you something. So, basically you have to guide targeting a blue image. So, you have bunch of computation going on, it really does not matter, it is a distance computation. But then you kind of want to say, oh, by the way, while you are doing whatever you are doing a great job, just do not forget about the color please. So, then it will generate the blue, but then this structure is just so fat, I do not like this. So, then you say, well, I know, thank you for taking care of the color, by the way you should take care of the edges or the size also. So, you kind of guide the diffusion model and then you are going to get the perfection. So, this is known of guided diffusion. All of them are basically in the work. So, now I am done with image generation. So, before I so machine learning model, before I conclude, I want to talk about just adversarial machine learning quickly, so that I get time for explainable AI. So, basically in the adversarial machine learning, the key idea is, if the attacker knows you are using machine learning to detect the attack, they or whatever you are trying to do, they will attack the machine learning model itself. So, there are different variations to it. This broad community is known as adversarial machine learning, and Dr. Karfa has one module dedicated for this. So, you will get more detail. So, in this particular example, this part this image extra pixel values, if you put into this picture, right, then this original prediction would be giant panda. If you put this thing, then it would be predicted as a bucket, another animal, totally a random animal, not even in panda category, it is going to predict. But the first attention people figured out when a stop sign was predicted as yield in a Tesla car. So, when it is a yield, it is supposed to just drive through. So, in a stop sign you are basically doing that. So, there are either you can add image to every pixel, but that original demonstration they put a tiny, let me take, if I can get a yellow, it literally of the size of a tiny yellow sticker, they put it physically on that big stop sign, not that big proportionally, even tinier square tiny yellow sticker was put in, and the machine learning model was identified that stop sign as a yield sign. Can anybody tell me why? Now that you know all these machine learning, one tiny sticker, any human will probably ignore it. It is a big stop sign like this, one tiny sticker of this size, really tiny. Why did machine learning made that mistake? Because machine learning, like our brain, it does not remember. You may think it does, it does not remember this picture, it does not take this picture and store in a data set, because you saw how I talked about classification. It look at certain feature, it does not even look at whether it is a character S or T or P or red, or what it captures nobody knows, that is the black box idea. That is this whole neural network, lot of weights, it tries to figure out something, some hyperplane, and tries to figure out whether it is a stop sign, or because of that black spot it becomes a problem. Even if it is a yield sign, police you thought yield sign, you drive through, hit somebody, or police give you a ticket for stop sign violation, how do you correct that model? Because you do not know what the hell wrong with that model, you have no idea. I trained it right, I studied all my life, I did everything, I am not getting a job. How do you fix it? Because you have to understand the problem.
Sir,
yes.
Sir, if we don't know about the reason why AI is raising such mistake, then how can we correct it?
That is the, you have to wait again 5 minutes for explainable AI. I should have started at 4 o'clock. So, give me 2 more minutes, that is why the explainability comes in. Okay. So, that is basically the idea of adversarial machine learning, and I am going to skip all of this because I want to talk about quantum machine learning. I was planning to talk about, I was planning to skip that too. I will try to cover some other time, because I want to talk about explainable AI. So, I will go through very quickly 3 examples. Explainable AI is a big idea. So, one of your colleague already asked the question, if you do not know what it is, what do you do? If your kid is not doing well in the class, what do you do? I have seen most people, they beat the kid up, keep beating until you have to look at her, she is getting high score in the class, why can't you get it? and then you beat up. You actually don't understand what, as a parent you don't understand what's the problem, why kid is not getting good score. So, idiot parents, which most parents are, they just beat up their kid. They want to just keep their responsibility. What you should have done, try to understand the problem. Maybe one of the teacher is not good, maybe math the kid previous class didn't build the background, maybe you need a tutor. Maybe the kid has some serious problem, want to find a boyfriend or girlfriend because there is a social pressure, everybody has one except. So, we have to identify that problem. Of course, kid is not going to talk. That is why life is so interesting. If everybody tells truth like me, life would be a better place. You just tell the truth. Nobody tells the truth. Everybody talks politically correct thing. I don't know why. It's all hush hush story, everybody. That's okay. Now, explainable AI, the idea is we want to know what's happening inside black box, why my kid is not getting score, so that I can make the right decision. If one of the cat it predicted as a dog, I want to go back and change the training process. So, if I know what went wrong in the training process, what did I do wrong in my life, that is also a problem. I made a mess up in my life and I will set the expectation high on my kid, that is a serious problem, because I won't be able to go back in time to my childhood or school days. I won't be able to undo it. Most parents screw their kids by setting that expectation on them, and they don't realize, but this is all from machine learning. So, first and simplest example of explainable AI is decision tree. I could have shown decision tree on the AI model itself when I showed support vector machine. This is actually even simpler model than support vector machine, where I showed a line to show separate. Decision tree, so this is again from malware, it is exact tree it built for one of our malware detection algorithm. So, this is saying number of instruction in the program greater than 1000. If it is a small program, I do not think it is a malware, that based on the training, that is what it learned, because the examples I provided, none of the examples had malware that smaller than 1000 lines of code. Then number of branches per instruction greater than 20%. In a normal program, 20% is typically kind of branches, if statements in your program. And then even within that, how many of those branches are mispredicted? Is it more than 10%? Then it is benign. If it is less than, then it is malware. So, there is all these partition. So, why is it explainable? If it predicted a program as benign or malware, you can go back through the tree and figure out the rationale. Why that is important? If it mispredicts something, you exactly know what happened, which branch you made a wrong decision, right, and you can modify it. Of course, that could be hack if you do not do it right, and we do hack all the, those of you who work in software company, I worked 7-8 years in industry. You just fix something, your boss is pressing on you, delivery date, you just fix something and you know that will fail, but I was counting on I will change company, I changed 5 or 6 companies. By that time they figure out there is a hoopla I did, by that time I left the company anyway, it is somebody else's headache, right. But anyway, jokes apart, you basically change one of those, maybe greater than 0.1, you want to do 0.15, but that would cover only the case where it failed, maybe another one it will fail, but that is the idea of decision tree. Anybody has any question on decision tree? That is an explainable AI. I want you to understand that the explainability, what happened in the decision making process, that is there. What you want to do with it, that is different. Use the microphone please.
Just to put it simply, isn't this just an optional elimination method? And maybe what you are saying is, if one of the criteria, let's say it's less than 1000 line of code, and still let's say like 1001, and still we are able to find malware, maybe my decision tree of certain branch, the decision is not the like accurate strategy. That option elimination will not work.
Absolutely, all I am saying is you know what happened, what you do with it. I never said decision tree is used widely, it is not used, its prediction accuracy is very low. I simply wanted to introduce the idea of explainability to differentiate whatever machine learning model we are building earlier, it built a line or a plane, you have no idea what plane, why, but here you exactly know that. So, this is the it gives you insight into the decision making process. so that you can interpret its decision in a human understandable way. You just don't beat up your kid because he or she failed in an exam. The next one is model distillation. I am trying to make it faster. So, the idea of model distillation is simple. You have normal machine learning model by neural network, which is telling you cat or dog. In parallel, you maintain another model which is called distilled model, that is why the name came model distillation, that maintains some other information. Now, in reality there is no two models, there is only one model, and these two models are kind of combined in a human understandable way. You will not be able to differentiate. So, it may the way in layman terms you want to think about it, it maintains additional information. How much, what, I will not explain for this example, I will explain for the next one. But its model distillation is an idea and it is not widely used. What is widely used I am going to spend more time, but what it does is essentially you are doing normal model training and you are also doing some kind of model training, model building for distilled models, so that all the features that you have, you are kind of maintaining a information. This is not like decision tree. Decision tree keeps every bit of information. Here you do not maintain every bit of information, only information you maintain which features are important. That is all the insight you get. If that is not good enough for you, then this is not a good model for you. So, I am going to spend little bit of time, again I am going to skip this is same as the example. So, this is one of the model training process, where you have some data set, then this is long short term memory LSTM, one of the neural network model, then you have MLP layer, softmax layer, kind of making the decision, and you are maintaining information. But I am going to zoom into, of course, that information what you want to use it for, you want to interpret. Remember the malware detection I talked about, different register, different clock cycle, it computes certain values for each of the row and column, and whichever value is higher, how and what I will talk about in other lectures, malware detection. When the value with higher value, that basically means that is important. That means something happened in clock cycle 4 during execution, that would help you debug, localize. You can just zoom into clock cycle 4 instead of millions of clock cycle trying to debug. If you compute the same way here and let us say register 2 has high value, then something happened in register 2 and clock cycle 4. That is the insight you get. What you want to do with it, that is your choice. You may not be able to do much. It is not like decision tree where you know everything, you do not get everything, all you get this level of information from model distillation. So, if something is classified at cat, it probably will give you a high value for nose. So, that basically it tells you this is the feature nose or something, it thought it is more important while it is making the decision. If you believe it should not have focused on nose, then you have to go back and tune feature and do some feature engineering and do something about it. Final one that I am going to spend little more time than the remaining 10 minutes is Shapley value analysis, which is widely used today, or variation of Shapley value analysis everywhere in explainable AI. So, before I promised I will not show any math, but this time I will, and but the thing is, before I show math I will to tell you a story. Let us say 3 faculty members, just 3 of us here, went to Las Vegas to gamble. Okay. Disclaimer, gambling is a crime, I never gambled even a penny in anything, but let us say we went there and we won. How much do you think it would be a good number? $1,000? We won $1,000. And then me being so arrogant, I am going to say I am a professor in UF, I must be most intelligent. So, I am going to take $900, remaining $100 you two of you can decide. Dr. Karfa is saying if it was not for me, GIAN course will not happen, 3 of us will not get together, we will not be getting this $1,000. So, I am going to be little humble and I will take 500, remaining 500 2 of you decide. So, everybody we can keep on arguing whole day, will never decide. Shapley value analysis says there is a solution to it. How about just I play alone and see how much I can win. Dr. Karfa plays alone and see how much he wins. So, each of the professor plays once and see how much alone, or then 2 of us play. So, then we are trying to figure out who contributed more then there is no more fight. I told you this story. How does it relate to machine learning? In machine learning, there are no professors, no gambling, nothing. Yes, yes, ma'am.
Same thing, on the basis of the features that I.
It's the features. Which feature is more important? The person here is the feature in that story. So basically, Shapley value, your idea is, key idea is marginal contribution. Every day I decided to put one equation, and today here it goes. And the reason I wanted to show that, I had to show this equation, otherwise I won't be able to show this example. So if I want to talk about 1, 2, 3, so 1, 2, 3, I took the example of 3 professors, let's put that name, and then the way we want to play is, if one is playing, which is me, let's say I am playing, I am 1, minus nobody playing, what's the profit? How much money can one person make? Then we are saying that 1, 3, 2, that order, or like let's take the last one, 3, 2, 1, that order. So 3, 2, 1 basically that order playment. So 1, 2, 3, all 3 of us played, and 3, 2 played, only I and Dr. Karfa played. So basically we compute all these, then we take the average of it. So this is basically minus one person and then taking the average of it. So Shapley value analysis said, once you compute the average, then we exactly know which of us contributed how much to that $1,000 earning. And in the machine learning example, who contributed to how much to that decision. Now let's look into how do we, anybody has a question on Shapley value analysis? This is an important idea. A very simple idea I want you to understand, so that there is no more ego fight. We can mathematically compute who contributed to, then it is not based on who is from USA, who is from IIT Guwahati, who actually contributed how much to that decision making process.
So these first two are same, 1, 2, 3 and 1, 3?
No, 1, 2, 3 or, oh, this particular, because you are doing only one, but difference would become obvious if you look at, let's say 3, 2, 1. So in 3, 2, 1, 1 came last. Who joined in the story last? So 1, 2, 3, 1 joined last. In 1, 2, 3, 3 will join last. So the way it would be computed, that's how it would be. I didn't show all of them, I just showed some random number of them. But we have to try all combinations and then take the average of it.
So initially that butterfly example, we had less number of something. So in terms of data, the bias was for a very odd number. In this, if we think of that, the smaller number, even though it's less, giving the result while training, it might be a significant factor. Maybe let's say orientation shape is very less likely to be there. But if it's there, it improves the overall accuracy.
Right. So that's exactly why it's average. Otherwise, I would say that okay, let's each of us play only once and then figure out or 2 at a time. That's why we are considering all combination, which is whole list is not there. Everybody plays in every possible order, and then how much money it makes, then you make the average of this to figure out. So I want to show you this usage in one of the stories. So again, Trojan detection story. So you have different benchmarks. Some of them has Trojan, some of them doesn't have Trojan, and then you have a set of features. And then you are doing a model training. After training, when you ask it to predict, it predicted the green one correctly, red one incorrectly, black ones it didn't know what the hell to do. But what is important is the features is ranked. I didn't give any name, just to give illustration, and you can continue this kind of story, and every second model will try to fix the error of the previous model. So I want you to clarify, this model is not more powerful than this model. This model might be trained for 3 months. This model was not trained, it's only trained to fix the bug of this. So this is not a plus of this model, then this model would have been the final one. But either way, the story is multiple simple model collectively would be more powerful than a big large language model, bulky large language model. And this is a common notion in industry, managers know it. Do I hire one person with a huge salary or lot of employees with low salary? If we can do it right, each has complementary abilities, nice group culture, one is good at software, another good at hardware, another good at analog, another good at integration, then that would be the right approach than hiring somebody with huge salary can do everything for solving the same problem in the same amount of, that is a bad idea. So, that is one, but another example I want to show you how does this work. So, here are some of the features, intrusion detection date will be more clear, I will come in, but just think about it, these are some name, does not matter, I am not going to explain what these are, RAS switches, dynamic power, number of nets in the design. So, when you add a feature, this is the highest ranking feature, this is the lowest ranking. When you add a feature, it try to pull in one direction. Somebody is saying, I don't think it's a problem, I think it's a good design. Somebody says, nope, I think it's a bad design. Wherever this one, think of tug of war, wherever it pull the rope, other one is pulling from that place and other one is pulling from that place. And everybody would be trying to pull either towards left to tell it's a Trojan free or good, other one is trying to pull right. At the end, the final result, and there is this magic number 2.192. If the final number is behind the left of 2.192, then it's a Trojan free. If the final number is on the right of this 2.192, then it's a Trojan. Where is this 2.192? Remember that machine learning model, the marker it came with, that line, magic line or the plane. Now, why this is important? Because now you know in the decision making process who contributed how much to that decision. So, Shapley value analysis, when I call it explainable AI, it actually does not explain like decision tree. Only thing it explains you the ranking of features. What you want to do with it? If it made a wrong decision, you kind of say, oh, I made you the manager and you totally put the group in chaos, I am going to demote you. And you as a individual contributor actually tried to show leadership quality and finally save the project, deliver on time, I am going to promote you. So, different features ranking, for right decision you reward them, for wrong decision you penalize them. So, it kind of inherently you think about it's a reinforcement learning story, that is how you will use, but Shapley value does not care how you want to use it, it just gives you a mechanism to rank the features when it is making the decision. And this is for one benchmark, and for multiple benchmarks, if you just do not want to zoom in for each benchmark, it is showing different benchmarks. Some of the benchmark finally got pulled to the left to say they are Trojan free, some of them gone to the right to say those benchmarks are Trojan inserted. I believe, oh, and then this is the final slide, where is all this getting applied? This is explainable AI is applied to many domains, and as I said 12,000 papers a year, 12 to 20,000 papers a year. There are even lot of approaches where normal machine learning model are becoming explainable. So, although I kind of tried to give you a flavor, machine learning and explainable machine learning, that boundary is getting blurred. Some form of explainability, almost every model is becoming kind of part and parcel of it. But the key idea is for subsequent of the 9 days, we are going to talk about how do we use this explainability. So, whether it is part and parcel of it or we have an explicit explainable AI model, I do not care for the subsequent days of discussion. As long as you are clear, explainability means it gives insight, but your expectation is not set, it will, I can ask any question and it is going to tell me, oh, that is not going to happen, that is not what is happening. And it is used in many domain, and one of the domain that most of you would be find helpful is debugging, why it created false positive, false negative. It is also you will be able to train better, because if certain decision it made wrong, you might figure, oh, I had less samples of cat, I may need to do little bit of retraining, or different kind of, as you can see in different communities use it for different things. That pretty much brings me to the conclusion. And so, there are a wide variety of machine learning model, and I talked about some of them, and explainable AI kind of provides insight. I talked about 3 of them, actually I talked about 2, and integrated gradient I forgot to mention, that is also another explainable AI model widely used, actually part of even most large language model. And in the next later we will talk about, in the tomorrow's we will use how explainable AI can be used for malware detection. So, first we will talk about what is malware or malicious software, and then we will talk about how explainable AI can be used for malware detection. Thank you.
So thank you, sir, for walk through the machine learning entire machine learning C. I mean, it's a amazing lecture, I would say. Starting from supervised learning to the generative AI in adversarial machine learning. So everything is covered in 2 hours, right? So it needs 2 years to learn. 2 years learning in 2 hours. I think it's a wonderful session for all of us to go through the entire machine learning thing without any equations, right? And that's the best part. So all of them, you believe there are a lot of equations. You open the book, when you open any online videos, you will see a lot of equations and you will get bored, right? 2 hours, I don't see anybody get bored here, right? So it's a wonderful session. Thank you, sir. So we'll end the day here. We'll continue again 10 a.m. tomorrow. So before 1 day up, I just want to ask you one thing. So Friday is holy, right? So I think it's inconvenient for everybody to come here, and when we schedule it, you realize that the holy is there. So there are 2 possibilities. Okay, I just try to see your opinion, and then we'll take a decision by tomorrow. The first possibility is that we drop 1 day's content, right, from the course. This is one possibility, and we'll see which day we can opt out. And the second possibility is that we move the Friday to Sunday. Because Saturday also, I think there will be post-holy thing in many places, right? So I have to see the logistical issues on Friday, Saturday moving to Sunday, whether the CET will support us or not. But I just take your opinion also, which we should follow, and based on that I can talk to CET and try to make sure. So what is the thing you want? Sunday. Sunday is fine. CET.
Number of hands for Sunday.
Sir want to raise 2 hands. Sir does not want to drop anything from the promise.
I came all the way, but the thing is CET may not be.
So I'll talk to them. So I think there is a very conscious.
No, let's ask the second question also. How many of you want to drop one of the day?
Okay, it's a wonderful thing.
Some of you want, I know, I can see in your face. At least in this class, one thing you learn, be honest. First to yourself and to everybody else. The world would be a better place. How many of you want to drop it? Drop one of them. Thank you. You are at least 2 hands.
Okay.
So there are the 2.
I think, but majority came all the way and they want to do. So I'll see Sunday if we can move it to Sunday. Okay, Friday we'll enjoy Holi. And we'll spend time with our friends and all. Sunday I'll just see. I'll try to insist CET to make it happen. And I'll announce about that tomorrow. Okay. So if there is no final announcement today, I'll talk to them and I'll update you tomorrow. Okay.
Friday is official holiday.
So it's not a holiday in IIT Guwahati. What I noticed is this is a no working day. In the sense there will be no classes.
No class day. No working.
Okay,
No class day.
No class day. So we have to come.
How many of you would be willing to come on a colorful day? Okay, so that's also another choice you have to keep in mind.
No,
I thought
think
it's a holiday on
No,
Friday.
the problem is that if they go to hostel for lunch, they may not be able to come back. They will be colors and all, right? So student will be in different mode that day, right? So I know that.
I don't know. Color, no color. Yes.
So Friday, how many have problem that we don't want to come on Friday and enjoy Holi?
No, it will be a problem.
It will be a problem. So officially in IIT it is not a holiday. So but
I'll
only it's a
come
no
in half
class day.
pant and some old t-shirt. And I don't care who throws how much color. Because external features are less important, including color. You can put water and you can clean it. Because Sunday we may not be able to schedule it. Because they are
So Friday, how many want to come? Please raise your hand. So all 3 possibilities are open, right? So I'll announce tomorrow.
Because Sunday they are government employees, they might not be.
And Friday, so basically this schedule was done 1 year back, and that time I had nothing. And I never thought about Holi, honestly. It only came to my mind when this Sunday my wife told me Friday the Holi hai bhai tumke aise class karo. So then only it came to my mind, right? So anyway, we'll figure it out tomorrow. I will announce. Okay. So thank you. Thank you for joining and listening all the day. And let us join again 10 a.m. tomorrow. Okay.